much arguing with people in the live stream text.
And it's hard to do it
because, I don't know, they think that flat can't mean curved.
It can't.
Well. I mean, can black be white? I mean, are we things are pretty defined properly. I thought we already figured this stuff out already. What's the confusion all of a sudden?
All right, so what does flat mean, Dog?
Sure, I've got an argument for it if you'd like to hear it.
Yeah, go for it, man.
Sure. So, flat can reference your position to something else.
Horizontal.
Curved,
yeah.
And something can be flat. In this case, flat references the height above sea level.
Yeah, and sea level's flat, so that means that your height above sea level will be flat and level. Correct?
No, because toe tanks show that.
Toe tanks! Oh, he's going off Mr. Sensible! Mr. Sensible! Oh no! Have you heard Mr. Sensible's clip in here? That's been debunked, mate. Those toe tanks, that is so stupid. He said it was 0.6 of a millimetre curve in 170 metres. You know what it's supposed to be? It's supposed to be 15 millimetres. So
that's not an argument for them being wrong, though.
Well, the curvature that they measured was wrong. So if it's wrong, then it's another black swan.
Where was it wrong? What specific?
Because the curvature on 170 metres is supposed to be 15 millimetres. They measured 0.6 of a millimetre. How does that make sense?
Where's the document for that?
They didn't actually measure it. They just assumed it. With the globe in mind, They just said, this is what the sagitta would be, therefore it is.
You're talking about the toe tanks, aren't you, that failed 2 months later because of concrete stress. You're talking about that, where they wind down the steel plate to match the water, to match the level of the water. That's what you're talking about, aren't you?
I'm talking about the Boulderwood towing tank, and I'm reading a CFD and hydrodynamics.
Yeah, we already debunked that, mate.
About it, and in that it says this: the master spirit level with a precision of 0.02 millimeters was used for roll adjustment, and a 0.3 millimeter Dyneema fishing line was attached to one bespoke winch at each rail end. This line has a breaking point of about 25 kilograms, and very little stretching, which allowed it to be very tight and reduce the catenary effect. A microscope was mounted on the rail to look down at the line and perform the adjustment with the height precision, and then it's got a set of figures here.
You've got no idea what you're talking about, man.
I just read it out to you. This is the document that I'm referencing.
Okay, can you show us? Can you show us the experiment and explain to us what it is? Go ahead.
Yeah, give the method.
Sure. So what they did is they had a rail that had to be the same height above a set of the tow tank itself, and that rail was curved, which when it's
show us the measurement of that. Show us the measurement. Stop. Show us the measurement of the curved rail.
Yeah, I just linked it in the chat.
No, you didn't.
I did.
Show us where they actually measured the rail to show a curve over it.
I'm going to link it in the chat again.
Great.
Done.
Okay, you just dropped your link again. Give us a citation from the link where they actually talk about how they measured the arc over the rail.
Yeah.
Yeah, page 2.
Okay, and how much did they measure?
So there's actually a towing tank dimension chart here.
Okay, and how much did they measure? Your robot and AI.
Okay. So what specific measurement do you want me to show?
Well, screenshot it and show us the measurement of curvature.
No, I dropped a link. That's good enough.
No.
You said no, it's not.
It's your proof, man. Bring the proof.
Yeah, it's my proof. I've given my proof. If you guys don't like it, that's your problem.
No, you haven't.
Reading a 120-page document, mate. Just screenshot.
It's not. It's 3 pages.
We do not care.
Okay, then it should be really easy for you to grab the citation, the part of the paper where they talk about how they actually measured the arc over the railing that you just claimed.
What? There's a set of references. Do you want the set of references?
No, dude.
One of the sets of references and then link that.
No, dude.
You haven't read it.
How about that? Since you guys have an infinite regression of bullshit you want me to show, but you guys haven't read a single measurement of flat, I'll do that then.
You haven't read it.
Yeah. So
you haven't read it.
He claimed that they measured.
I just read it out to you, you idiot.
You didn't read out. You didn't read out what you were asked to read out, though. You claimed they measured an arc over the railing, right? So we're asking for the part of the paper where they talk about how they did that. Yeah, you did. Now you're just lying.
No,
they measured a curve over the rail.
What I said is that they measured that the railing was the same height as the water, okay? And then what they did was they got the fishing line, which is at the bottom of the second page, so it's referenced as page 32. The bottom left-hand paragraph, they got this fishing line, they stretched it taut, and then they had a microscope mounted on the rail to look at the line and make sure that it fit the water line. Which
he just assumed is curved. Yeah, so he just assumed a curved water line. You matched some railings to that, and then there's your curve. Okay, so
that's what the fishing line was for. The fishing line was there to show.
How do you make sure the fishing line's level? How do you make sure the fishing line's level?
You don't make sure the fishing line's level. Have you never used a line before when building?
Well, have you ever stretched a line till it's level? How's that possible? Over 170 meters. How's that possible?
I'm sorry, that's not what they used it for. They used it to show that there was a deviation between the ends of the lines and the middle of the line.
Right. Well, for that, you'd need
a string line before?
Level. Have you? Yeah, I'm a builder, you dumb cunt. So
then you've used a string line. So why the fuck are you asking me how string lines work, you idiot?
It's only got a certain length that you can use it over because it dips in the middle due to weight.
Yeah, that's why they use this specific Dyneema fishing line, which has a 25 kilogram breaking point.
Doesn't matter, mate.
Very little stretching. It says specifically
over what distance?
Little stretching.
Over what distance?
I don't know what the distance was that they stretched it.
So you haven't read it?
I have read it. I'm reading it right now.
Tell us what the distance is then.
Oh my God, guys. You want me to bear down on the very smallest details.
It's your fucking evidence.
So you can just deny it, because that's all you have. Deny an argument from incredulity.
It's your evidence. You're bringing evidence. You don't know what you're talking about.
Every other piece of evidence that's ever been brought forward.
What evidence? You haven't given us any.
Do you want me to just look up more tow tanks that say that they had to match the curvature of the Earth, you fucking idiot?
Yeah, go get another one, because this one didn't do it. You just assumed the curved water line.
This one did.
Railings to it. Shut up. I'm still talking. I'm not done. I'll have to mute you if you don't stop. Yeah, you just assumed the curved... Shut up. You just assumed a curved water line, then you matched some railings.
All you're doing is denial. It's pathetic.
You haven't... Hey, dogs, you haven't brought any evidence for us to deny.
Exactly. Yeah, you just assumed a curved water line. Shut up. You just assumed a curved water line, matched some railings to it, right? And then there's your curve. But it's just in your head, though. It wasn't actually physically demonstrated. You're just begging the question of a curved water line, then you match railings to it and go, there's your curve. It's stupid,
physically demonstrate something.
So, yeah, you asked, should I go get more measurements of curve from other tow tanks? Yeah, go do that, because this one wasn't that.
Gotcha, bitch!
Great, you want me to actually go and find some measurements now?
Yeah, yes, actually find the measurements.
We've been waiting for you.
Don't lie to me, buddy.
That's what you were supposed to do the first time, Ding Dong.
I don't have to. I'm just referencing something that says the Earth is curved. You guys don't even have that, you useless fucks.
We observe the Earth as not curved, so what are you talking about?
Yeah.
No, you don't observe that.
Yeah, you do. You observe the same Earth as everyone else in this panel, so don't be delusional. We all live on the same Earth as you.
How funny? No,
you guys
is that?
You guys don't have any evidence of flat. I have given you a document.
You
want me to find more? Like the Humber Bridge, because we talked about that the other day. The Humber Bridge.
Yeah, that's full of shit, mate. We can throw that one out.
You're stupid to understand what a plumb line is, you dickhead.
Oh, yeah. Curvy ones? Are they curved?
Projection.
Don't get all salty now that I'm using swear words and calling
people salty. No one's salty. We're just talking about how the water under the bridge, what it's not doing. You know what it's not doing?
Not a hill of water.
So you can have your curved bridges, but you don't have any curved water.
The distance at the base and the distance at the top are different. So that means it doesn't matter.
The water doesn't
understand how it works.
You've never built anything. You've never built anything in your life, mate.
Mate, I had to explain to you what a string line is, you fucking idiot.
Well, that's why I build houses every day, mate. So you don't need to explain to me how to build.
You fucking nail some shit that someone's going to come along and fix later, you dumbass.
Are you an idiot? I'm the actual licensed builder, mate. I do it from start to finish.
You've never done that.
I'm the licensed builder, man.
Are you?
I do it from start to finish. Right?
No, you haven't. So don't lie to me. You don't know what a string line or a plumb is, you idiot.
Okay, I don't know what a string line or a plumb is.
Yeah, I've taught you what both are.
You haven't taught anybody anything so
I've been building houses since I was 16 years old, you fucking moron.
Yeah.
You don't even know what a plumb line is.
He doesn't know what a plumb line is. He had to be taught just a minute ago that the lines can actually sag. He's just retarded.
Yeah, you don't know what a plumb line is on the potato earth that you're trying to use plumb lines to prove. So that's a big fail for you, buddy.
As this guy, I don't know what a plumb line or a level is. I'm holding one in my hand.
Damn. Listen, dogs, let's just bring it down a few levels, dude. Obviously, you guys join, you want to have a conversation, but, like, obviously barking like dogs, no pun intended, isn't a good conversation. So let's bring it down a few levels. You can make your point. Just chill out.
The reason I come in all hot is because I've come into this server a few times, and you guys have done the childish muting, name-calling thing. So I'm just coming in to match your energy. I'm happy to match a different energy if you present a different energy.
We'd appreciate more.
You can control yourself. We don't need to control your mind.
More swearing can help you.
I got different energy if you want a different energy, mate.
Cool.
Get him, Jedi.
So we have multiple bridges that all have the same deviation of the towers at the top compared to the bottom. Why is that?
Show it.
Strength.
See, that's all you're going to do. You're going to ask me to show it. Okay, I'll show you right now. Maths side notes. It's about the Dogsaregods Narrows Bridge, and I can get the Humber Bridge one as well if you'd like.
I've got the Humber one.
You're going to say, how did they measure it, or what measuring tool? No. And I'll explain what it is, and you guys will do something like, but plumb is wavy, and you'll make up all this bullcrap. Even though plumb is wavy stuff didn't actually.
It would be on the
Let's not assume what the jury's going to, think about your evidence. Let's just present the evidence. I think Jedi wanted to kind of get his feet wet here. So what's up, Jedi? Let us know what you think.
Also, I'd like to mention, don't say that we are making up this plums are wavy stuff. That's your religion. That comes from the folk
and last time someone presented
and you didn't know about that stuff.
It didn't actually say plums are wavy.
Yeah, they are wavy, and it did say that you just didn't comprehend what you read, as always.
You can get some minor deviation due to mountains, but that just proves gravity exists, which proves the Earth is curved. So which one do you want? Do you want Earth curvature due to gravity, or Earth curvature due to plumb being used on tower bridges?
Gravity.
Yeah, I went through the citation for whoever just popped this image into chat, and that's a graph. That's not like a representation.
Scientific experiment that proves gravity, please. You just claimed it. You've got one, so give it.
Great, plumb lines.
No, that's not a scientific experiment. Hold on. Sorry. 2 seconds. I asked specifically for a scientific experiment.
Yeah, plumb lines.
Plumb lines is not... No, scientific experiment, cause and effect. Plumb lines is just a word. Would you be able to give a hypothesis, please?
Plumb lines deviate due to large, massive objects, like mountains.
Like mountains.
Do they?
Yes.
Have you got a citation and experiment for that?
Well, luckily enough, this citation that someone popped into chat just before says plumb line, direction of gravity. So plumb line's dependent on the direction of gravity. So if you guys want to use the citation of wavy plumb lines, you also have to...
That's still not science, little man.
It is science, yeah.
No, actually not. It's not an experiment. It's not science.
Yeah,
what's the independent variable?
The independent variable would be the
mountains.
Mass of the object, and the dependent variable would be the deflection of the plumb line.
Phenomenon.
How do you manipulate the mountains?
You move the plumb line so that you manipulate the mass effect on the plumb line. So you don't move the mountain. It's the same as like instead of moving a big set of bricks away from something, you move something away from the set of bricks. It has the exact same effect.
So is this mass attracting mass?
Yeah, that's what these plumb line curvature. See this one, Flat GPT just put it in. Earth's gravity field is shown in Figure 4.1. This
Awesome
also
stuff.
references Earth's gravity field's effect on a plumb line. So, which one do you guys want? Do you want to use your citations for plumb lines being wavy, or do you want to admit gravity exists? Or say gravity.
First of all, hold on. Sorry. Why are you talking about mass attracting mass? Why are you talking about it being? Hold on, but it's 100 years out of date. Yeah,
no, it isn't.
It's 108 years out of date and superseded by Einstein.
No, it isn't.
They couldn't.
Einstein just gave the underlying cause. It's still mass attracting.
No, he didn't, and he wouldn't be able to do a physical. Hold on, you told me not to interrupt you. I'm not. Don't interrupt me. What is physical about Einstein's bending and warping of space-time? What is physical about it?
Sure. So two massive objects will change the underlying quantum field of space-time, which will cause it to curve, which will cause an apparent attractive force between two large objects of mass. So mass causes the change in the space-time, and that change in space-time causes an apparent attraction.
Awesome. Would you like me to point out the reification fallacy of two non-actual things, space and time? Because they're not physical, are they?
They are, yes.
No, they're not. You can't give me... Hold on. Listen to me, young man. So when we're talking about space, you realise that's the absence of anything, better described as nothing.
That's the colloquial word. You're confused between colloquial and the physical definition.
Oh, so you have reified... Hold on. So you have reified it from non-existence...
How'd you get that from me explaining that you were confused about the definition used for that specific word?
I'm still trying to figure out how you...
My friend. One used by laymen.
Yeah, okay, so my friend, how would you make space physical? Being as I've misused the word...
The interactive sum of all things. And space has an underlying electric field, as well as you have things like the Casimir effect, which is when you actually create a perfect vacuum with with zero particles in it, particles will come into existence.
Okay. Let's just do it like this. Has Einstein got a scientific experiment, or is it just math and equations?
It's predictive evidence. So he gave a set of predictions.
Hold on,
which is scientific evidence.
That's not true. Hold on, that's not true.
It is
true.
No,
isn't. No, I've asked you this question.
Do you want me to go through all of these experiments that prove
my Australian friend. All right, I'm trying to have a conversation with you. I'm trying to ask you a very simple question. All right, very simple. I don't understand why you keep jumping through it. I really don't.
Well, what I'm doing is explaining something, and you're not understanding.
Fuck me. Right, seriously. What do you want me to do? Bend over for you while you fuck me? It's not happening, mate. What I would like you to understand is science deals with the physical things. I've asked you, is Einstein scientifically proven or just mathematical equations? Is it mathematical equations?
So Einstein gave mathematical equations which have then been scientifically proven.
So
what's the problem with that?
Hold on. So he didn't and hasn't provided a scientific experiment. He just provided some maths. So he didn't provide a scientific experiment.
There's nothing wrong with that. You understand that I can come up with whatever hypothesis or theory I want, and if someone else was to test that and show that it's correct, then it doesn't matter that I didn't do it.
You need an observation.
Einstein didn't do it, did he?
It doesn't matter if Einstein did it. Why does it matter if Einstein did it or someone else did it?
Because Einstein's talking about math. Could you then give the scientific experiment that has proven...
I just asked you a question, and your answer was because Einstein was talking about math. Do you want to try that again, buddy?
Yeah, I do.
So mathematical equations. This is my specific question to you. Why does it matter if Einstein came up with a theory and someone else was to take the predictions inherent in that theory, test them, and show that theory is true? And your answer was because he was talking about math.
What did they do? Who and what did they do then? Being as it wasn't Einstein who just had maths, what did somebody else do? Because that was the first fucking question. Because I want the science, because you claim science, give the science, not the math.
Do you want to know what Einstein did or what other people did?
Well, we've discovered what Einstein did. He didn't do science. He did maths. So let's go to the people who proved it with science. You dumb fuck.
Wonderful, great. So do you know what the time difference between a satellite and the Earth is?
Yeah.
You know what
Are you going to be talking about the vibrations of cesium atoms?
No.
Oh, that's a shame then, because I definitely don't know what you're talking about, being as those are the things that they have in atomic clocks.
Yes. But satellites don't
no, yes,
have atomic clocks.
What? Satellites, atomic clock, what? No, yes, what?
You brought up atomic clocks. What I'm saying is satellites have clocks. The Earth also has clocks. If you send a satellite up and that satellite moves, then the time on that satellite will be different to the time on Earth.
That's because they're atomic clocks. You dumb fuck.
These aren't atomic clocks, not on satellites.
Oh, they're not. They're just clocks that are sometimes wrong. What are you talking about?
No, not sometimes wrong. Like
how are these clocks manufactured? What are they using to keep time?
The exact same thing that your PC would use. It's just a chip and then a simple program that would track the time in the exact same way your computer would if you were to unhook it from the internet.
So you don't know what cesium is.
Satellites up, and then when they sent the satellite up, they found that there was a discrepancy, particularly GPS satellites, between the time of the satellite and the time on Earth. And then when they looked at the relativity, and particularly I think it's called Lorentz contractions, they adjusted using that Lorentz contraction inherent in Einstein's relativity to make sure that satellite time would match Earth time. So they had to actually change it at a set rate. So it wasn't just some random deviation. It was actually applying a mathematical formula from relativity to the satellite in order to make the time sync up, because Einstein said that things moving at different relative speeds will experience time in different ways.
That's an affirming the consequent formal logical fallacy.
It is not affirming the consequent. And affirming the consequent
would
be if there was no other explanation. But I've ruled out the other explanation.
No, that's not how affirming the consequent works, little man.
Relative time. And it was a prediction, so predictions don't work.
A fallacy is a fallacy regardless of what nonsense you try to waffle on with.
Do you know what an affirming consequent fallacy is? Can you explain it?
Yeah, if P, then Q, if Q, therefore P. Yeah. Would you like an example of it? And then would you like me to point out how you've just used Einstein's maths, just pointed at the clock and said there can be no other explanation. It has to be this. It can only
I said that the other explanations were ruled out because they used that mathematics to fix the time difference in the clock. So if you can give me another way that they could have fixed that time difference, then sure, I'll admit that it was affirming the consequent fallacy.
Yeah, I can't.
Is there another reason why? Is it so? There's no other reason why those satellites would be exactly out by the exact amount predicted in relativity.
Yeah, I don't know. Where are the satellites?
In space.
How do you have gas pressure without a container?
Cool. So I'm going to give you a very quick analogy, and you're not going to understand it, or you're going to be, intentionally obtuse about it. So if you have a billiards table, you played billiards before?
Pool and snooker, not billiards. Maybe you call it something different. Might be the same fucking thing.
That's fine. I was just using one that would be sort of like a more universal term, billiards, but we'll just call it pool. So you got a big pool table, right? And that pool table is perfectly level. So that means that if you break, then the pool balls will go off. They'll deflect off the sides. They'll deflect off the back. They'll deflect off each other. And they'll sort of randomly place themselves throughout the pool table. Now, if you were to have gravity, which is bending and warping of space-time, which causes an apparent acceleration, that would be equal to chalking up one end of that pool table. So then when you break, those pool balls, sure, they'll bounce into each other, they'll bounce off the sides, they'll bounce off the back, but they will always be moving more towards whatever side is lower on the pool table. So there is an apparent acceleration on that pool table and the pool balls to make the pool balls move towards one direction. And that's what happens on Earth due to mass, bending and warping space-time, causing an apparent acceleration on
particles. It doesn't happen to gas, though, so you're wrong there. We actually see the gas go up and not just down, so you're wrong.
No, I'm not. That's why my analogy is so good.
Oh, you are. I can show examples of it under all laboratory conditions.
And bouncing off
under all laboratory conditions. I'll just mute you. Under all laboratory conditions, gas expands upwards to fill the available space. At no time does gas go down, go boom boom, and start acting like liquid, because it is actually gas and not liquid.
You don't even need to add the qualifier under laboratory conditions. Just, anywhere ever known to man ever. Like, that's how gas operates. Anywhere.
Yeah, and all the laboratory conditions, are they done in an atmosphere on Earth?
Wait, can you repeat that?
We see the gas.
Wait, what? Repeat that question? What?
Sure. So all the experiments Drace just mentioned, the ones where you say were to open a pressurized container and the atmosphere was to dissolve into the lower pressure space.
Oh, no. That's not what I said. I said under all laboratory conditions. Shut up, little man. You don't know what you're talking about, so I'm just going to tell you. Under all laboratory conditions, like I'm showing here in this picture, you have a container with gas in it. You have a container with no gas in it or very little gas in it. And then when you open the valve between them, the gas goes upwards, filling the available volume. It is not restricted by any down vector. Otherwise, if the second law were violated, like you say, by gravity and prevent it from going upwards, you would be unable to exhale. So you're just as wrong as can be, and you prove yourself wrong every time you breathe.
Another way you could say that is you might be able to exhale, but I wouldn't have so much confidence that you'd have air to inhale after you exhale that time around. The heliocentric model was true, vacuum in space and all that.
Sure. So what you have wrong about all of this is the amount of pressure and the pressure difference.
No, you're an idiot. God damn.
No, I'm not an idiot.
Yeah, you are.
Sorry.
Let me just try to say
similar pressures in those.
But let me try to say this in the most simplistic way. If you can't get this, then I don't know what to tell you. So take for instance, let's focus on real life examples of gas pressure in the consistent X value form that we have.
Are they done in a container? Are they done on Earth? Do they reference the Earth? Are they actually matching analogies, or is this just something that is completely different to what we say the Earth, space, and atmosphere are? Because it's completely different.
Bill, you're going to slow down. Shut up. I didn't say anything about analogies. You just said something about analogies. I didn't say anything about analogies. I'm talking about, let's start with real world examples, practical demonstrations of gas pressure in the X value form that's consistent. Starting with, take for instance, our car tires. So we have car tires, all right? Most car tires, with the exception of trucks and stuff like that, bigger vehicles, most car tires typically have about 36 psi around the rim contained by the tire. All right, so that's the X value inside the tire. There's also delta X, but whatever, it's just different delta X, different directionality in the tire than it is in other places. But anyway, the point is you got X and you got delta X inside the tire. So that's one example of consistent gas pressure inside of a fixed volume with a container, and it's consistent. So we have that example. We have, inner tubes. We have, pumps of different kinds. We have balloons. We have all different forms of gas pressure and sealed greenhouses, by the way. They also have sealed greenhouses that also present another example of gas pressure in the X value form. So then the question arises, if you're going to claim that gas pressure here on the surface of the Earth is caused by gravity, then the question arises, do you have any demonstration, a practical demonstration, a real-world demonstration of gas pressure in the X value form consistent, caused by gravity without a container?
No, I don't need one. And all of your experiments were of things in containers. So how does that prove that something not in a container wouldn't work?
Hold on, friends.
First of all, I didn't say anything about experiments. I just said demonstrations of gas pressure. I said
why bother? He just admitted, right, that in order to have a proper analog, you must experiment on gas pressure outside of a container, thus conceding that his position is unfalsifiable in principle and therefore not science and can be summarily dismissed.
No, it's easy falsifiable. You just go up into space. We did that. Congratulations. We showed that there is a difference between.
No, you're just appealing to the future. Oh, we could go into the future, into space. But we can actually show that gas does not behave like you claim, where gravity is supposed to be the strongest at Earth's surface.
Yeah, what's the difference between the gravity at Earth's surface and the gravity at the edge of the atmosphere?
Irrelevant, because your imagined gravity is not holding gas down where it's supposed to be strongest.
Yeah, do you remember my analogy?
Yeah, you admit it now, so you don't have any gas here on your globe anymore.
Hold on.
So you don't remember my analogy because it's the pool balls bouncing into each other. So the pool balls.
Why'd you give an analogy?
In all directions.
Yeah, your analogy is false.
Towards one.
Your analogy is false because you're looking at physical solid matter balls rolling on a flat solid matter that's being angled upwards, and so naturally it will go down. Gas is not solids. Gas behaves completely differently. You are making a false analogy.
And you must also understand with the inverse square law that the distance of mass and your gravity is going to reduce in power. So saying is the gas is moving away from the strongest point of the gravitational pull of the Earth, and as it gets further away, the gravitational pull of the Earth gets weaker. You've got a fucking problem.
No, we don't. We don't have a problem because
it gets weaker with distance.
Towards the ground. So what you have to have is you have to have that gas bounce into another particle so hard that it shoots off into space.
Where's the gas produced? Where's the gas produced?
The gas is, well, at the start of the Earth, the gas was produced from rocks, chemical interactions in rocks.
Yeah,
release,
so we'll understand
oxygen,
that the gas is produced.
Carbon.
Hold on. So we understand that the gas is produced at surface level or within the mass of the Earth, right? Chemical and biological cycles. So the gas that you are saying, I'm going to get to the point. Obviously, that's why I'm talking. Good. I can't get to the point whilst I'm making a point. I can't say two things at once. Right. So being as the gas is produced within the Earth, the largest pole of the mass, it is then escaping the Earth, fucking off. And when it gets to, the inverse square law that I mentioned earlier, as the mass of the Earth's gravity reduces with distance, it's get weaker. Why is the gas turning around and coming back then? Being as it's getting weaker with distance.
Sure. So the gas, it doesn't just all come out of the Earth, okay? We have like a big system, a very dynamic system. The gas is moving around.
You're not answering his question, little man. Try to pay attention next time and answer the actual question. You want to repeat it, Jedi?
Yeah, being as the gas is produced within the chemical and biological cycles of within the Earth and on the Earth, and being as we have to take account, the inverse square law, being as gravity is stronger at ground level and gets weaker with distance, and the gas is produced at ground level, how is it even escaping the fucking Earth and then at the weakest point coming back?
There are less particles to bump into each other that high up, therefore they can't bump into each other as much, pushing them upwards. That's the most simplistic answer. Imagine the pool balls again, and at the very top of the table, there's only like 10 pool balls, and then you get much closer towards the
end. Yeah. If there's more space for the gas to move in, and the gas is going up, what the fuck is making it turn around?
Yeah, keep in mind that you're already seated, that there's nothing for them to bump into. So their directional vector is just going to remain.
Have you never used wind to create more wind?
What?
You blow, you go, right?
Yes, you already conceded the point that there's no wind forcing them back down.
I haven't conceded any point, you idiot.
Yes, you said it yourself, not 30 seconds ago.
When did I say it? You tell me exactly what I said, please.
You said that there's not enough collisions up there to redirect the gas.
Yes, because there's less particles per square inch.
Right, then you appealed to them being redirected by the collisions.
They hit each other, and then some go up, and the very, very light ones, because gravity doesn't affect them as hard can hit each other at such a amount, such a high speed that they will go away from the Earth far enough to escape the gravitational pull.
What about the other ones?
They will hit each other. They may move up for a little bit, and then the gravity, the consistent apparent acceleration on them, will cause them to come back towards the Earth.
So you only gave 2 types of gas particles. What about the ones that hit nothing and just keep continuing in their same vector?
They don't do that because gravity...
Holy crap, dude. You just shot yourself in the foot, dude.
How? You guys
just said there's only 2 types of particles, and they need that redirection to then be redirected towards the Earth for gravity to take hold.
You discounted dog breeds when talking about dogs. Do I say that there's only 2 dog breeds?
Oh my god!
Excuse me, dude. Dude, don't interrupt me to talk about dog breeds, bro.
Well, don't tell me what I'm saying if you can't understand what I'm saying.
Dude, I can say whatever I want to paraphrase what you're saying, and then you can reply after the fact. There's no reason to be so jumpy, okay? Your mother's life is... Friend, your mother's life is not at stake.
So you didn't then go and waffle on about something you don't understand. And then I'll correct you after.
Pay attention, friend.
Just say, no, you're incorrect about this thing. Maybe
you are incorrect. You are incorrect. Yes, you are incorrect.
So... why wouldn't the particles come back towards the Earth if there was gravity high up?
Friend, I haven't finished my point, friend.
Go ahead.
No, it's not go ahead, because what's going to happen is I'm going to start to do it, and then you're going to interrupt me, and then I'm going to ban you, and you're not going to be welcome in the server anymore. So you make your choice right now. Okay, let's try it.
See what happens.
Let's see how it goes. Here's how it's going to go. Okay? You have gas heading upwards, right? From a previous collision. Or from pressure, whatever way you want to call it. It's heading up, away from the Earth. It's on that vector. Gravity is not pulling it against itself. It then goes up to the top, and you're saying it's either going to hit some other gas and be redirected down, where then gravity can, recollect it back towards the Earth, or it's going to hit and veer off upwards and be lost forever. But you didn't categorize the third gas particles, which just continue unimpeded because they never hit another gas particle. And you then said that they don't do that. Now, that's an accurate description of what you said.
Nope, not at all. So, you said...
all right, so here's how this is going to go, friend. Here's how this is going to go. You're going to bet money. Sorry, not money, because we don't do that here. How much do you want to bet? Since it can't be money, let's make a wager. How confident you are that that's not what you said.
I can just respond to what you said with what I actually meant.
No, friend. It's not about... I said what you said.
Playing some stupid game?
Okay, so now you're not confident enough in what you actually said. You want to recorrect it?
No, I want to tell you why you were wrong. Because remember at the start of your what you just said that I said, you said, oh, you can wait till the end and then tell me how I'm wrong. So I'm going to do that now. Is that okay?
Yeah,
go ahead.
The words back.
Awesome. So you said gas heading upwards from collision. That's true. It moves upwards away from the Earth, but this is at the very edge of the atmosphere that this will happen. On the ground, it'll move upwards a little bit, but not quite as much. And then gravity is not pulling it against itself. I don't know what that sentence means. Gravity is not pulling it against itself. Can you tell me what that sentence means?
Yes, if the gas has its own velocity, right, that it gained from collision, that force is present, causing it to continue in a direction, has nothing to do with gravity. So the gas, that's what pulling against itself means. There you go.
What is pulling against itself is nothing. Pulling against gravity would be what you'd be talking about, right? So
the gas is trying to go in one direction, and the gravity's trying to pull it in the other direction. Okay, it's not that hard to follow.
And what's wrong with that? So if the particle hits another particle and goes off towards space, and gravity is consistently pushing it against it as an acceleration, it would cause that particle to move back, unless that particle was very small.
Okay, that's a cool story.
To escape the gravity of the Earth, right?
Right. So what about the particles that just keep going up and never hit another particle?
That's what I just talked about.
No, you didn't.
Yeah, the ones on the edge of space that hit and have a velocity.
Right. So then why not 2 minutes ago? Why not 2 minutes ago did you spaz out when that's what I said?
What did you say specifically? It wasn't something you just...
You gave two types of particles. You gave 2 types of particles. One that towards the edge of the top of the space, right?
I understand.
It bounces off another particle, it bounces down, or transversely, it bounces off a particle and bounces up. And I said, what about the ones that just keep continuing straight up? And you said, oh, that doesn't happen.
No, I didn't say that. The problem was that...
You sure about that? That's exactly what you said verbatim, dude.
When you said two types of particles, I thought you meant like hydrogen, carbon, and oxygen. But what you actually meant was the two types of interactions, the two vectors.
Yes, what I told you was there's not just two, there's a third type, which is ones that just continue unimpeded and never bounce into any other one. Because like you said, there's less particles.
I'm pretty sure I mentioned that with like hydrogen and helium because they're such light particles that they...
Yeah, I corrected you and then you spazzed about it.
Away from Earth. But that doesn't matter because it doesn't matter. I've explained it all anyway. If there's a particle that hits with such velocity and its vector is away from Earth, then it can potentially escape the atmosphere. But if there's a constant acceleration applied to all particles, no matter how they hit, there will be a bias back towards the Earth. That explains the pressure gradient. It explains why we don't just randomly lose all our atmosphere all the time. Yeah, I mean, I don't see why this doesn't.
Right. So then, why isn't gas held to the Earth at lower levels?
It is. We have.
Why can't you reproduce this in a vacuum chamber where the gases you claim just sit at the bottom of the chamber?
Because vacuum chambers are very small.
It doesn't matter. All that matters is the amount of available space for the gas to fill. If you're saying that a vacuum chamber doesn't work because when you turn the valve and let the gas in, it fills the chamber, then you're debunking yourself.
No, the problem is that vacuum chambers are very small, which means that the gas inside of that vacuum chamber will be having more interactions with each other, or we won't be able to test if there's actual, a lot of particles in that chamber. But I don't know. They might have done this experiment. There might be an experiment out there with a vacuum chamber where they've shown that there is a bias towards the, gravitational acceleration.
So far, it doesn't exist. I've looked and looked and looked, and all I see is gas expanding to fill the available volume. Anything else would be a violation of the second law of thermodynamics, and I give your theory nothing but despair.
Well, no, it's not a violation of the second law of thermodynamics because there's a force applied to those particles.
Gravity.
What force?
We've had this conversation.
Gravity. How many times do I have to say it?
But we've had this conversation earlier regarding it not being a force.
It's an apparent.
Yeah, we also showed you demonstrations of the second law where gas is expanding to fill the available volume against your presumed gravity. And gravity is not limiting or preventing this interaction or overcoming the second law. So you're just wrong.
The second law of thermodynamics doesn't say that gas will fill a lower pressure system.
No, it's talking about hold on. It's talking about the movement of energy. So it is a direction. Exactly. So high pressure will go to low pressure environments. It will disperse this way, like a hot cup of coffee.
Force applied to it.
But gravity is not a force. We've had this discussion.
So it acts the same.
It's an apparent force that we can think about as a force, but isn't actually a force. It's not a force.
Yes, it has all the properties of a force. We just don't understand.
That doesn't mean it really is, but
it just doesn't have energy. That's all.
Level.
Yeah, let me read you something here.
It's really low, and I want to turn you up.
In simple terms, the second law is an expression of the fact that over time, ignoring the effects of self-gravity, differences in temperature, pressure, and density tend to even out in a physical system that is isolated from the outside world.
Very interesting. So wait a minute. So you're appealing to a force called gravity that's holding the gas to the Earth. That's your appeal?
Well, from the very start, I said an apparent force. So
whether it's a parent force, whether it's a parent force, or a teenage force, or a custodian force, let's just call it a force, for lack of a better term.
So an apparent force.
That's what you're appealing to.
If you were to get a bowling ball and you were put
nobody cares, dude.
I'm sorry. Am I upsetting
answer
you by
the question?
No, dude. You don't understand. I just rhetorically conceded your point for sake of argument. I don't then need you to go into it and explain what it is.
I was explaining for everyone else that doesn't understand that apparent forces exist all the time.
Well, let them tell us how that bowling ball proves the globe.
Great. So if you put a bowling ball on a flat bit of ground and you were to push it, then it would roll in that vector at that velocity that with the amount of energy you put into it. But you can put that bowling ball onto a slope, onto a downward slope, and it would still roll. It would increase its speed. It would have a specific vector that it would move on, but you haven't applied any force to it.
Right? Correct.
False.
Correct. No, stop, everybody, stop. He just said if you put it on a slope and it rolls down the slope, no force is applied. We know that the claim that causes things to roll down slopes is gravity. Therefore, he concedes gravity isn't a force, and we're back where we started.
Yeah, it's an apparent force. That's what I was describing. So in both our realities, and the one that you...
Right, so what you just described is a circular tautological reasoning.
No, it isn't, because you guys...
Yes, it is.
...explanation for that bowling ball rolling down the hill.
That now you have a logical fallacy that if somebody else doesn't have the answer, your answer is correct by default. That's false.
No, that's not what I said. I said we both have the exact same experience in reality of an apparent...
Right, but you said that your claim is correct because we don't have a counter explanation.
No, I just said that your...
That's what you just literally said, friend.
Incorrect. Your model of reality is incorrect.
Friend. Can you be honest with the way you speak?
You apparent force to work on that bowling ball if you
I don't care. I don't have to. It's not my claim. You're the one who made the positive claim.
Down the hill.
Dude, I don't need to. And notice how you just phrase that. Notice how you phrase that. Well, then how do you? Or you don't have an explanation. Therefore, my explanation's correct.
No,
by implication.
My explanation's correct. I'm just pointing out that you guys don't have an explanation, and that sucks to be you. Seems like your model.
No, actually, it's quite simple. And so let's just concede to your rhetoric, right? Okay, if you want to claim that there's a downward vector, okay, is that your claim?
Yep.
Wait a minute. Yeah, I didn't understand that. I speak English.
Yep.
What's yep? I don't understand yep.
Yep is yep. If you don't understand it, that's you problem. Everyone else in the call understands it.
Oh, really? Oh, so you're an ableist, huh? My native tongue isn't good enough for you? So is it a yes or a no?
What I am is not a child. It's a yep.
Okay, so what we have here, friends, is a child who can't frickin' speak correctly. So let's just say he said yes, since he seems to think that that's what you guys think he said. But I clearly was asking him because sometimes when you enunciate words that aren't actual words. So anyway, that's fine. So you agree in the affirmative that you are claiming. Okay, fine. Who cares, dude? Let's move on. Tedious. You're giving the positive assertion that the reason the bowling ball goes downwards on the slope is because there's an inherent vector of down causing it to happen, correct?
An inherent vector. Yeah, sure.
Okay, perfect. I would agree with you that down is down. Now, what you need in your worldview is inwards towards the center of a floating space ball. So you just conceded down, which is parallel to level, right? So you conceded plumb and level, which is 90 degrees to a horizontal plane. So you just conceded that the Earth is flat because you believe in down.
Didn't at all. Plumb is just horizontal to, is not horizontal, is 90 degrees to a single point.
You can't have 90 degrees to a point.
With a vector.
Right, so what's it vectored off of?
Gravity, the center of the Earth.
No. To get an angle, what do you need?
You need one line. So in this case, the plumb line is actually the singular line.
No, you can't get an angle off a single line. Holy shit, dude.
Yeah, of course you can.
How?
Both sides of that line are 180 degrees. Anything that it's a right angle to that line will be 90, 90, 90, 90.
Okay, so you're just saying a straight line is 180 degrees. Now, if you want to fix it to have down, right, you'd have to fix it horizontal, correct? Or you'd have to fix it vertical, correct?
You just need it to sit at a point on a string. It doesn't matter if you fix it horizontal. There's just a single point, a string, and a second point, and that'll give you a line.
Okay, so if you don't fix the 180 degree line horizontal or vertical, then how do you have any definition of down that's coherent?
Because you fix 2 points, and one on a string that has weight, and the other one is a fixed point in space, and it will give you the downward vector. It will point.
Okay, perfect. And that down, you would say, is a 180 degree line, correct?
Yeah, sure. Why not?
Okay, that's called plumb. 90 degrees to that is called level, which is horizontal.
Yeah.
Correct?
Yep.
All right, perfect. So the Earth is a horizontal plane. Thank you.
Why?
Because you just conceded that that's how you get plumb.
Do you want me to open Paint and show you what I mean? I'll open Paint and show you what I mean.
Yeah, you go ahead and show me something that's not down, because down is down, brother.
Mm-hmm. So
down is perpendicular to the horizontal plane. That's how we describe down in how we live. You don't have an example of anything to the contrary. Oh, and by the way, friend, you appealed to gravity to substantiate your down. And I don't know what type of gravity that you appeal to, but none of them are relevant to disproving that down is 90 degrees perpendicular to a horizontal plane.
What type of gravity I appeal to? There's only one type of gravity. It's mass attracting mass.
What? Whoa, bro. Who told you that? What, have you not made it to university yet?
Teachers, intelligent people, things I read. Pretty much anyone that isn't a flat earther trying to straw man what we actually think.
Dude.
What
modern citation, right, about the cause of gravity in the modern relativistic paradigm claims that it's mass attracting mass?
All of them?
No.
Do you want me to?
So apparently you've never heard of the bending and warping of space-time?
Yep. But I went through this before, didn't I? The bending and warping of space-time is caused by the mass of the objects.
Dude, that's not mass attracting mass.
Yeah, the bending and warping causes an apparent acceleration towards the center of mass.
That's not mass attracting mass. That's not mass attracting mass, friend.
Which causes an attractive process.
No.
What about what I just said is incorrect? And don't just repeat an assertion, actually go through it and tell me how I'm incorrect.
Dude, it's very simple. Attraction means that the quality of the mass, without any other intermediate, is causing the other thing to move towards it. Right? So if you had the masses...
No. Why did you say no intermediate?
Oh, yeah, you could have a string. You could have a literal string attached to the other, and you could be pulling on the string. But that's not what's happening.
A not physical string, so something that you can't physically see and touch.
Correct, but that's not how that's described in space-time, brother. There's nothing reaching out and grabbing the other object and pulling it towards the other object.
Sure,
there's no attractive force.
Analogy time. What we have is we have two things sitting on a piece of like heavy cardboard.
No, you're not using that, friend. Let me tell you why. No.
Smack the middle of the heavy cardboard so that...
Right. Then you're appealing to down because
caused by
you're appealing to the slope. You're appealing to down again, which just proves the horizontal plane.
Doesn't.
Yes, it does.
Right now,
listen, friend, you cannot get those objects to move without gravity being down.
Why?
What do you mean why? You're telling me that if you can't appeal to gravity, that you can demonstrate to me objects moving if you smack a piece of cardboard and create an inclined plane.
Yeah, of course.
Wow.
There are millions of different forces that apply to things all the time. It's very hard to correctly with 100% certainty. It's impossible.
Oh yeah, you could use a magnet. You could put a magnet under it.
Different forces.
Yeah, you could use metal balls and put a magnet under it, and that would have an attractive force.
Great.
A true attractive force.
So, why can't gravity be an attractive force? You haven't given me a reason yet.
Yes, I did, dude.
All you said was that their bending in space-time facilitates it, and therefore it can't be an attractive force of mass.
No, that's what it is in the mainstream rhetoric, dude.
Yes, it is a
tangible action through free space between one object and another causing gravity has been abandoned for over 100 years.
Say that again.
Yes. Any type of tangible action between one object and another object existing in free space, right?
Yeah.
Has been abandoned, dude.
No, it hasn't.
Yes, it has.
Okay.
Yes, it has. Also, you didn't know that most physicists are pretty convinced that Einstein's theory is wrong, according to Sabine Hossenfelder, a PhD in physics?
So most physicists disagree with Einstein based on a single physicist?
No. She's reporting the general consensus within physics, within highly advanced physics.
Oh, is she? Do you have, like, say, a survey of physicists that agree? Or do you just have the singular?
I also posted above here. This is
a second
from,
physicist.
American Institute of Science. The 10 biggest unsolved problems in physics, and among them is gravity or quantum gravity. Because they cannot...
quantum gravity! Oh, we've completely moved away from the real world into the quantum realm.
No, that's why Sabine Hossenfelder is talking about. She's saying that most of the physicists today understand that the general relativity in Einstein's theory does not function with quantum theories, and so they're looking for quantum gravity or something else because they realize that Einstein's theory does not much experiment.
Let's stop right there, though. Let's stop right there. We gotta set the record straight real quick. Okay, this guy was just told about quantum gravity and quantum theory, etc., and he acted as if it's ridiculous on its face. When quantum mechanics and the subsequent theories thereafter are some of the most scientifically, experimentally validated concepts in the history of science. Right? So this kid clearly is not up to speed with the modern rhetoric, clearly doesn't understand that they abandoned mass attracts mass, clearly doesn't understand that the scientific validity of quantum mechanics, etc., is moving the paradigm ever forward into something new, which will abandon relativity and space-time interpretations of gravity. Clearly, this kid is uneducated and not capable of having this conversation. I rest my case.
Okay, cool. So the problem is that quantum physics seems to have different constants than the physics that we interact with particle physics. So having a theory of gravity for particle physics can be 100% correct for particle physics, but it may not be correct for quantum physics.
For people like me, that will not change anything, because in reality, that everything what you are saying now, it's clever and good, but in reality, that photo should occur, and that will be only reason that I can change my mind, because I believe more reality than all this story what I'm listening like for 1 hour. Einstein, blah, 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 blah.
Yeah, Sasha's on point here. So I'm going to speak to Sasha now for a minute. So Sasha, if I'm not mistaken, you heard him appeal to down constantly, which I basically told him down is perpendicular to a horizontal plane, which is how we all experience it, level, which is how we experience water, which makes up 70% of the Earth's surface. So he's trying to piggyback down, which we all experience, and shoehorn it in as inwards into a giant space ball. Now, Sasha, as an observer who hasn't been participating, at any moment, did he prove his inward towards a giant floating space ball? Or did he just try to appeal to down, 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 downy, downy, down?
Do you remember the tower bridges I talked about?
Listen, friend, is your name Sasha?
Can you repeat, AI, what are you asking me?
I'm asking, this entire time he's been appealing to down, right? And down is perpendicular to level, because down is plumb, right? And water's level.
Yeah.
So where did he prove inwards towards a giant floating space ball, rather than just appeal to down like we all experience, and then expect us to make a fantastical leap that somehow he proved inwards.
Well, in that books, I don't know, in that belief, what he's believing in that, what he's telling us, like we have now all definitions, everything, but nothing about reality. That means, okay, everything what you said, it must function in reality. What he said, let's say, gravity pulls here, gravity pulls gases. Okay, great. That means that water has drop over distance in reality, and it's all right. And then that we will observe.
Yep.
For sure.
But let me pause you there, Sasha, because down and gravity pulling things down has nothing to do with curved objects. Gravity pulling things down is perfectly congruent with a flat surface of the entire Earth. Now, our astute friend here will then try to make arguments based on physics, based on a caricature of a flat Earth being a thin disk rather than a thick substrate or a disparately massed substrate, right? That would end up with the same vector lines on the surface. But it's irrelevant because down and any type of gravity that makes things go down, even mass attracts mass, even Einsteinian space-time relativity, which by the way is just a density distribution, no matter which way you do it, they all work perfectly mathematically fine to create a vector of down in the math if the Earth is flat. So it's really a moot point. Now, Sasha, you did bring up a very good point, though. It's like if the water isn't curving, then it can't be a globe because the globe requires curvature all the time, every day, all day.
Yeah.
Sorry.
Is this
Go ahead.
Can I leap in?
Sure.
Yeah, it's the interesting thing that I've noticed with the more kind of like hardened seasoned ballers is that they like to take a phenomena that everyone agrees on, like, you know, the acceleration towards the ground, 9.8 meters per second squared, and then they like to take ownership of that as a globe phenomena, right? So then they say, oh, you can't explain it on your flat Earth because we've already explained it on a globe. Well, the issue with that, of course, is that you can do the same experiments, you have the same phenomena, and if you have a different framework that makes the same prediction, then it's equally as valid scientifically, and they just don't accept that.
Well, yeah, and then what they'll do is they'll straw man the position. Like, oh, if the Earth was a flat disk, 1 millimeter thick, then this is what would happen.
But the framework itself because it's rotating and it has gravity, it would be a ball.
False.
Yeah, the framework is assuming mass attracts mass in the first place, which is also up for debate. So it's like you just reassert the thing that's in contention.
I'm sorry, is there any experiment that shows mass doesn't attract mass?
Okay, so that's proving a negative. Can you actually prove the positive?
Yeah.
Yeah, friend. That's not how they do. That's not how they do science. They don't create a negative proposition and attempt to prove a negative in science, dude. Where have you been? Now we're not going to move on until we address your claim.
Two massive objects and set up a scientific experiment to test if those.
Hold on, irrelevant. Hold on. We got to address. We got to address your caricature, which I predicted. Hold on, friend. Sure, but anyway, let's address the first claim. Which, if the Earth was a giant disk spinning and it had inwards gravity towards the center, that it would collapse into a ball. That makes zero sense because the forces would be distributed in a planar nature towards the center. So where's the torsion force?
The torsion force would be between the. It would have to do with the spin.
Okay, once more time. You have a center point. You have a disk. Let's imagine a record. Let's imagine a record. It's spinning around a center point. The disk is evenly distributed mass. The gravitational quote-unquote force, allegedly, is pulling towards the center. Okay? Since all the mass is evenly distributed in a planar nature where every mass is stacked upon itself, 180-degree lines to the center, right? And centrifugal force is outwards in the same vector, but in the inverse direction, okay? There's absolutely nothing that would collapse that into a ball.
Okay. We wouldn't have
because there's no forces perpendicular to the surface, dude.
We wouldn't have downward force in your hypothetical Earth.
Hold on, friend. I'm not the one who caricatured the flat Earth as a flat disk with almost zero dimension. You did.
No, I didn't. You did that. You said I was going to. I said it still wouldn't work no matter how you do it. And then you said if it's a flat disk rotating around a single point, and then I said there'd be no downward acceleration on that. So I just said according to what you
No, friend. You are.
Or do you want it to be flat and rotating?
No, friend. You, before that occurred, made the straw man that the Earth would be flat in the sense of nothing below it.
Nope, never.
You did that. We all witnessed it, brother.
I said
not only that
below it. That's you.
No, that's how you characterized it.
Nope, didn't.
Okay, fine. Let's say that's true.
Bruh.
Okay.
So something flat.
Then you've just ruined your point. You just ruined your point because all I need to do to create a vector of down, according to you, is just have a substrate below the surface.
No.
Problem solved.
Have people on the edges would have a diagonal downward force. So
no, that's not true. That's not true, friend. That's not true, and I could provide you a university professor paper that demonstrates perpendicular field lines that are parallel, that roughly match what we experience on Earth, which is down everywhere we go, simply by having a deep cylinder with disparate mass distribution. Okay, so you're wrong, categorically wrong, evidently wrong, published wrong.
Does he take into account the rotational forces?
Good day, sir.
Dude, why would you assume there needs to be a rotation?
I don't. That's just what we experience in reality.
Where?
No. Star Trails, Mickelson, Morley. I mean, all sorts of things.
That's not experience.
Mickelson, Gale.
Whoa.
So can I just leap in on that one?
Yeah.
So you're you're just asserting what's already in contention. So we have a sidereal rotation, right? We understand that, but how do you know that it's the Earth moving and not the sky moving?
Any ring light experiment will show you that.
Any what?
Ring light. So where they get light, they split the beam and then they track the time it takes for that split beam to hit a central point. If
so you're talking about
that means there's been some motion through space.
You're talking about Mickelson-Morley, right?
Well, Mickelson-Gale tested it. Mickelson-Morley was testing whether there was an ether, and they got a null from that. So.
Yeah, but you know that they.
No, they were testing. They were testing motion through the ether, not just ether itself, brother. So please characterize it correctly before you straw man it in your favor of your bias.
Yeah, they still didn't show that the ether was there, but there was still. They said that the only other cause would be something like the Earth turning.
That wasn't the purpose of the test. He just explained it was motion through the ether.
And they still got a null hypothesis.
Okay. What do you think?
Gale did it later to test if it was Earth rotation, and they.
Yeah, they got a null on motion, bro. They got a null on motion. Good grief, dude, you're slow.
Sorry, who got a null on motion?
Oh my goodness, dude, Mickelson-Morley, duh.
Yeah, but they weren't testing motion. They were testing if there was an ether that they were moving through. That was a specific.
Wrong. They were testing motion through an ether.
Yeah, exactly. So they
not ether motion. Motion through the ether.
They weren't testing.
Holy crap!
The Earth's rotation, were they?
No, they were testing the Earth's motion through the cosmos, bro.
Through the cosmos, through the ether, which is what they thought caused all this.
No, dude. The motion of the Earth alleged through space, like around the sun, all these other heliocentric baloney sandwich claims.
They were testing for ether wind.
No.
They were.
So do you think the relativity is
ether and relative motion implying that so-called ether wind should exist? That's what they were testing.
Wrong.
And how they tested
they did They did find something they did call an ether wind, but that's not what they were testing for. That's not what they claimed to be testing for, so you're just lying.
They didn't find an ether wind.
So I still don't feel like you've really fully answered my question. So, or answered it at all. So, how do you know that based on this, that the Earth is moving and not the sky? If the null hypothesis was what they found.
So I referenced Michelson-Gale as well.
He must be referring to the corroborating experiment of Airy's success.
Michelson-Gale showed that there was like the Earth was spinning.
No, it didn't. How so?
Sure. So what they did was they set up an interferometer.
Right.
Oh, actually, no. Maybe this one's different. What am I looking at? Michelson-Gale Pearson experiment. Yeah, with the Sagnac effect on an interferometer.
Right. Can you cite that?
An interferometer splits the beam of light, and then if there is any motion in space by the Earth, then it would mean that beam of light, when it after it had been split, would have two different velocities.
Do you understand the words that are coming out of my mouth?
Yeah, can you cite that, or are you just like stating things?
Yeah, I'll just send you the wiki. You can look through it. It's got references to the actual experiment if you want.
Yeah, no, I'm aware of the experiment. I'm hoping that you would be able to link me to the conclusion that you think it made.
The Michelson-Gale Pearson. Yeah, the outcome of the experiment was that the angular velocity of the Earth as measured by astronomy was confirmed to within measuring accuracy.
Okay, so how do you know that that's the Earth spinning and not the sky?
Because it was measured on Earth and not measuring anything to do with the sky. Is there any force the sky gives us?
Well, okay, so you know that relativity says that if the sky is moving or the Earth moving, that would produce the same results.
Sorry, can you say that again? I didn't hear.
So the relativity states that if the sky or the Earth are moving, they will produce exactly the same result.
No, it doesn't say that.
Yeah, it does.
No, it doesn't.
Yeah, it does.
Okay, can you cite that? Reference it?
Yeah, well, I'm driving, so I'm not going to pull over to...
Oh my goodness, dude. Just send him the wiki so he can peruse it at his leisure. Kind of like when he cites things.
Yeah.
Kind of like when he
Well, I also just read out the results.
This freaking... No, bro. Hold your horses, bro. You've been here, right? Ask for citations. References is fine. That's fine. But that's not a citation. A reference is not a citation. Okay, so if you want to use these words, go find a reference for what they mean, and then bring us back the citation of what they mean. Thank you.
So, can you tell me why relativity says that it would be equal if the sky was moving or the Earth was moving? Sure. So the definition of citation, a quotation from a reference to a book, paper, or author. And the definition of reference, number 2, is the use of a source of information in order to ascertain something. So I'd say those are synonyms. You disagree?
No, not even close.
Awesome.
Dude, have you taken any collegiate or university level courses?
Yeah, I have, but why does that matter? Are we in college?
Have you done references and citations? Well, have you done references and citations?
I'm sorry, I didn't know that I was currently doing a college course on flat Earth in this Discord server. So, can I not use synonyms? Is this like whoever said, what was it before? Someone said the
colloquial... A reference isn't a synonym for a citation, dude.
What was the the colloquial term for space. Someone used a colloquial term for space instead of using the actual physics term of space, right? So am I not...
Why should they use a physics terms?
Well, we're at a collegiate level to debate right now, aren't we?
There's no debate. You're just flailing.
So we're not. So I can just sort of like give the references a wiki article that has a list of the actual copies of the scientific paper. I can do that, can't I?
Right. That's not a citation, though, friend. That's the difference. You're offering references while asking for citations.
To reference something is to point at some source of information, like a...
Right, that's not the same as citing it. That's not the same as citing it.
I can cite a reference, and I can reference a citation. Are those two sentences equal?
No, they're not.
So if I cite a reference, if I say, oh, my reference for this is my friend Jason X, who this is his phone number. And if I reference a citation, I say, oh, my citation is the one written by Jason something, here's his phone number. Is that not equal? This is just...
No, because now you're mixing categories.
Do you guys have any reason why Michelson-Pierce scale didn't show the Earth was in motion?
Oh, yeah, because they had to apply a mathematical transform to fit their bias in order to get the conclusion that they wanted.
My boy just realized he goofed up and tried to run away from his own little example.
No, I'm just tired of the semantics. It's pathetic.
It's not about semantics, dude. It's about earlier you were asked to cite something that you offered as a reference, and you just told people to just read it. And I was just pointing that out, that you're a hypocrite.
How? I read out the result.
Okay, look, fair enough. Okay, maybe you're not a hypocrite. Maybe you just are ignorantly think that references and citations are the same thing. We'll forgive you.
You haven't given an argument why they're different. You've just said, are you doing a course? And I said no. Do you want me to read out dictionary definitions again?
Dude. Okay, for example, if he asks you for a specific piece of information about something, right? And you say, I'll give you the wiki in total.
Yes.
You're referencing the wiki. Now, if he says, I want this specific piece of information, you go to the wiki, pull out the citation, give him the citation from the reference that has a specific piece of information. Those are entirely two different things. They're not synonyms.
You think that citation has some different meaning.
Dude, I just explained it to you. Very simply.
From or reference to a book, paper, or author. That's for citation. For reference, the use of a source or information in order to ascertain something. Provide a book or article with citations of sources.
Oh my goodness, dude. Dude, you're wrong.
He's stupid.
You forgot the word specific.
To specific. No, it says or a specific reference.
Oh, a specific reference.
Yeah.
Not a general reference.
Citation definition.
Holy fuck, bro!
Quotation from or reference to a book. So that's the noun definition for citation.
Yes, and where's that in?
It is used in the definition of citation. You understand that, right?
Dude,
quotation from.
If you're asked for a citation, yeah, you need a citation is a specific.
Have argument for flat Earth.
Yeah, you already conceded down is down, and water's flat and level. Therefore, the Earth is flat. Welcome.
Tower bridges show that Earth is not flat and level.
How?
Story tanks show Earth is not flat and level.
No, wrong. You failed to provide the citation that you were asked for about the tow tanks, how they specifically measured curvature.
No, string line.
You failed to provide the citation, friend.
No, you just didn't like the citation.
No, you didn't have a citation. You just generally said the term string line, just as you did again now.
And?
Watch. Ask me how, just ask me in the reverse. I want to play role play so you can see how stupid it is.
Yeah, sure.
Ask me how to prove, or what proof I have that the Earth is flat. Ask me that.
What proof do you have the Earth is flat?
Lasers.
Cool. Do you have a reference for someone claiming that lasers show the Earth is flat?
I do.
Awesome.
I have an 120-page PDF and an accompanying documentary of the methodologies and the practical tests that they did. And I also have a citation from their document that says the WGS-84 model is not found in the field.
Great. Link that and I will read it. See how that works?
Okay, perfect. Now, actually my friends are going to link it because I'm going to speak. So, links, FE Core, for my friends who are using the bot, and then exclamation point videos laser short, exclamation point videos laser long. The short version is a condensed version that you can watch, and then the long version is the long version, obviously, that you can watch when you have more time. Now, I'm going to give you the practical methodology because I'm capable of... Hold on, friend.
I wanted to... Oh, no, it's a PDF. Okay, we're all good.
Oh, my fuck, dude. Did I not tell you what was coming down the pike? I said a PDF.
But then you spoke about long and short videos, and I wanted the PDF.
Yeah.
I don't know if that was being linked as well. But someone linked a PDF.
Yeah, fair.
I do.
No, all right, good.
Where?
Oh, yeah, it's my turn to calm down, bro. Were you not on calm when you began? The answer is yes, so fair is fair. Yeah, anyway, let's move on. When you asked for a citation of the methodology that they used with the string to prove curvature over the distance, you weren't able to provide it. You didn't cite from the text, and you didn't articulate the methodology. You didn't cite it from the text, nor did you articulate the methodology. But I'll tell you the methodology from this laser test, right? If you want to listen, I'll tell it to you. But you can also validate it from the document. So this is actually multiple tests, culminating in the final biggest test of 25-mile sample size over water, right? So there's 14 or 17, I can't remember correctly. But the longest one they shot was 25 miles. So what they did is they set up what's generally known as a laser transit, right, methodology, which is you have a laser, you level the laser, you shoot the laser across, and then you use what's called a storyboard or a receiver that's at the same relative height. And then when it hits, you see where the laser hits, and then you can tell how off it is. We use this in construction all the time to level foundations, excavate, all kinds of stuff. Very practical methodology, very simple. So if you have the laser set up on one side, right, about 2 meters, 6 feet off the ground, and on the other side you have the story or the target about the same, 2 meters, 6 feet, right? The globe Earth predicts a differential between the off angle that the laser should continue into the sky if it's perfectly level and the target at that distance to be 90 meters, right? So in other words, the big hump of Earth curve water and the level laser, right, can't shoot through the hump of Earth curve water, so it shouldn't hit the target. It should go over the target by 90 meters. Now, when they set this up, right, they took into account the ambient conditions. They took into account the millirad divergence of their laser. They created, which is in the documentary, a very accurate aiming device and leveling system. And if you watch it, you'll see how precise it was, very precise.
Type of laser was it?
Well, you'll have to look into there. It's a big old laser. A laser sufficient to shoot 25 miles with a very limited millirad divergence.
Yep, I read that.
So sufficient to the task. And they might talk about the type of laser, because they actually had two. I think the first one failed or they destroyed it. But anyway, they talk about that in the thing. And they give the specs for it. So they did the test.
It doesn't matter. Refraction wasn't accounted for.
Says who?
Them. As light travels in a straight line through a homogeneous medium, light angles due to different refraction indexes in a non-homogeneous atmosphere. We calculate direction and amount of refraction to show how much laser beam deviation affects the measurement outcome. In a non-homogeneous atmosphere where the index of refraction increases with height, rays of sufficient small initial elevation angle of refraction.
Holy crap, dude.
Is proportional to the rate of increase of the bi-directional index of refraction.
Yeah, you just said they didn't account for refraction, and then they went on to say we accounted for refraction in the very text you just quoted from.
Yeah, but they accounted for it wrong. And well, actually, they didn't. So they're saying that it's a homogeneous through a homogeneous medium. We calculate direction amount of refraction in a non-homogeneous atmosphere with the index of refraction. Blah blah blah. This curvature is proportional to the rate of increase of bidirectional index of refraction.
Yeah. Anyway, so they set it up. They set it up, and the laser hit the target. Okay. Now, you may claim they didn't account for this, they didn't account for that. That's fine. but at least they have a practical example of their methodology.
Here we go. This is because I've read through this before, actually. Here's the problem. So the lake was partially frozen, therefore walking along the beam on the ice or using a boat was not possible. There's no data on the ambient conditions along the laser beam were available. We measured the conditions at the measuring.
Yeah, which site? Which shot is this? Which shot are they talking about?
I don't know. I'm just reading out of the text document for refraction conditions, the PDF.
Which test? Which test was it? What location?
Point of laser beam.
I told you there was about 14 or 17 different ones, dude. You can't just pick one at random.
Well, this is their heading for refraction conditions.
Oh my goodness, dude.
So they said when they measured refraction between the
which location? Which location?
Why does that matter?
Maybe because, listen, friend, maybe because over time and at each location they learned things and improved their methodology.
Then why wouldn't they add that in under the refraction category or subheading?
Dude, how many different shots were there? How many different conclusions?
Right now.
I don't know, dude. How about you read the whole entire thing? How about that?
Yeah, I thought so. You'd run away from this discussion because you don't actually...
I'm not running away from it. I'm asking you specifics about the thing, and you're not giving them.
Bruh.
Now, by the way, in the final 25-mile shot...
Temperature was 2 degrees, the air at night was 3 degrees. Humidity is always higher the closer you are to the lake surface, which indicates a lower refractive index. They just assumed a low refractive index. They didn't actually measure one. The ambient conditions showed that the refractive index
which location?
Was the two sides of the lake. So it didn't measure the difference across the lake. They just measured one side of the lake, the other side of the lake, and said, yeah, good enough. Am I wrong?
Yeah, maybe at that site that's what they did. But which site are you talking about?
The refractive, measurement number 1.
Measurement number 1.
Find the actual spots where like,
oh my god, dude.
Balance on Vallegos observation points. And
is it observation
laser position?
Yeah, is location number 1 the one where they state that the WGS84 model hasn't been sort of upheld?
No, that's just their first one they did, dude.
Well, that
anyway. He won't even make it onto the rest, dude. He's just going to look at number 1, say they didn't account for refraction curves light.
Was still at 0 degrees in the air at the night, was down to -11 above the air. Air temperature at the time of the measurement was -6. The ambient conditions showed the refractive index were about the same at the two sides of the lake. So they've just done the same thing, two sides of the lake.
Yeah, so the point I was trying to make is that if it's the first measurement that doesn't state that the WGS84 model is invalid, then what they did there isn't relevant to this argument. Cricket.
My argument was their methodology was incorrect because they didn't
measure
the refraction across the lake. They measured it from 2 points, the start and the finish. And if the beam was to curve, it would curve between the start and the finish, not starting at the start and ending
Fantastic.
At the finish.
So is that location 1?
Yeah, and location 2, they use the exact same methodology.
Is location 1 the, let's just call it experiment?
Stop for a second and listen to what I'm saying.
No, I'm not
just read location 2 and they use the exact same methodology.
I'm not going to stop talking, right? So the issue is that if they are not using location 1 as the quote-unquote evidence for the WGS84 model being invalid, then it's a waste of time to analyse the methodology there.
The second one did the same thing. All of their measurements, they just measured the temperature at the start and at the finish. They didn't measure the refraction between them. Do you understand that, Crypto? Do you understand what I just said to you?
Is location 2 being used to invalidate the WGS84 model?
It doesn't matter because they use the same...
Fantastic.
They use the same way of calculating refraction in all of their experiments.
The conversation. You're just wasting everyone's time.
What did I just say to you, mate?
Yeah, I heard what you said, bro. It's irrelevant. AI, can you tell me which location was actually used in this argument in terms of the WGS84 model, and then maybe we can read that.
Oh man, the only one I was talking about was IDSIL, the biggest one.
Fantastic.
Calculation of third measure.
So we're going to look at the methodology there, or we're just going to ignore
that? Condition shows the refractive indexes were about the same at the two sides of the lake. The same methodology. It's a failure because of that methodology.
Which location was that?
No, I mean not really, dude. You can interpolate the lake, bro.
Lake Isle or whatever that is.
I mean, unless you think that there's going to be a dramatic change in the middle.
Yeah, of course there will.
Okay, let's say that's true.
The middle is over water. Do you not understand that? The start and the finish are both land, and the middle is water.
No, they're not just like in the middle of land, dude. They're on the coast.
You idiot. They're both on land, and the beam goes across water. Those are two completely different sets of air they're going to be going through. One's going to have
a frozen
constant...
lake?
Sorry?
Isn't it a frozen lake?
Partially frozen lake, but you understand that
right, frozen water,
exothermic and endothermic effects.
Dude, do you really think that you're just going to use 4-syllable words and that's going to frighten anyone here?
You know what exothermic and endothermic means?
The frozen nature. So the frozen nature of the lake obviously changes the refractive properties of the air above the lake, doesn't it?
It does, and they should have measured that, but they didn't.
Wonderful. Yeah, but obviously you're saying it's water, which is being dishonest because it's partially frozen.
I'm sorry.
Also, we don't have the burden of proof.
I'm sorry.
Also, we don't really have the burden of proof there because your side has never proven that the light is bending around the globe to make it appear flat.
That's true, brother.
That would happen.
What the? Yeah, you do.
We say refraction would change it so that any observation we can have a certain deviation. If you take refraction into account, it will always fit the globe.
Yes, dude. Did you not just hear the words that were coming out of your mouth? Hold on, friends. What did he just say? He said, no matter what observation you make, it will always fit the globe. Wow, very scientific. You just ceded that any observation that supersedes the globe geometry, you just add the word refraction and it magically cures it.
Yeah, sure. It's like when will water boil? If you add pressure, suddenly it'll change, won't it?
Yeah, sure. We have an unfalsifiable tautology that begs the question and inputs values up into 60 billion mile radius to account for refraction.
What question am I begging?
Listen instead of talk. Maybe you would know.
What question am I begging?
The globe in the first instance, brother.
No, we've measured it.
How?
I just told you there's tow tanks, there's tower bridges.
No, stop right there, friend. Stop right there. The tow tanks, you didn't give us the methodology of measurement. The towers, you didn't give us the methodology of measurement. You just claimed them as a positive assertion. And then when I asked you what's the methodology, you simply said the word line. Fishing line, I think, was the actual word.
You're choosing to ignore all the times I read it out and just focus on the one time where I said string line.
No, I listened to you read it out, and that wasn't a sufficient methodology to see that the entire bar was curved, dude. It was segmented. You didn't even explain to the person who asked you. You didn't even explain to the person who asked you how they did it.
As you guys like to make globers do, you're willing to concede that I didn't just say line in all instances. Can you concede that?
No, I'm saying when I asked you.
So you're not going to concede something that you just admitted to?
Dude, when I asked you, it was correct. You just said line. Previously, you read something out about a line. Listen. Previously, which I already had just said, you read out something about a line. You were asked to clarify how it was done over the entire thing. You were asked to point to it, and you didn't.
I didn't what? What was I meant to point to?
How they applied the fishing line to prove that the entire structure was curved.
I read it out a couple of times. They put it at 2 points with a microscope pointing at the fishing line.
Yeah. Right.
Yeah.
And what did they do then?
A reference that they would then move the beam so that it had the correct amount of curvature according to that reference.
Okay, hold on, friend. Pay attention now. If you pull a line taut without the catenary curve in existence, you'd have a straight line.
Yes.
Right? So unless you have a benchmark, all you have a straight line. So if you then...
You can have a calculation of the amount of curvature that you want in that thing according to the reference.
Bingo. I want everyone to stop right there and notice how if you take a straight line and just calculate how much curve should be there, you can then make the claim that curve exists and that you've measured it. Slow clap. Slow clap, friend.
They did correctly.
No, friend, stop. You're assuming the water's curved, bro. You have flat water.
And then you
hold on.
The thing that you're making.
Right, so my friend, hold on. The previous guy who you asked 30 minutes ago, he critiqued you that you just assumed the water's curved, put the line parallel to the water, and then put the beam parallel to the line that's parallel to the water and assume that all three are curved, and then call that a measurement. That's what you did, brother.
No, I never said the line was curved. Remember catenary effect? I said specifically it wasn't curved. I read that out to you multiple times.
Okay, so let's be clear. If the line isn't curved and you parallel the metal to it and it's parallel to the water, then that means the water's not curved, and that means that the rail is not curved.
A reference didn't parallel it. You ever used a straight line before?
I build things, brother.
Great. So I built a fence not long ago, okay? And my fence, it was a picket fence, and that picket fence went up and down, up and down.
Correct.
Fences do. Right.
Absolutely.
Line, and then I referenced the amount that the middle picket would be up off this straight line. And from there, I could reference out the curve.
Perfect. So where did they do that in your example?
I just read it to you. They had a microscope that pointed at the string line and at the beam thing, and then they calculated how much they'd have to have of curve on that beam to match the water on an earth of a given radius. And they referenced the distance between the string line and the beam on the road.
What was the length of the string line? I
don't know.
Well, that done fucks it up, doesn't it, brother?
No, a gap in knowledge doesn't mean that the whole thing can be thrown out.
No, I'm saying if the string line isn't known, right,
God, what's the name?
And it's not sufficient to the task, and then you give us the answer that's not sufficient, that's going to screw up your argument. So how about you go get us that information?
Well, he also just justified all of the laser measurements he just got shown because like a gap in knowledge does not disqualify the argument. So apparently he just justified all of the laser measurement. Thank you very much.
What did I justify?
You said there was if you have a gap in your knowledge that doesn't disqualify it, and you said that we don't know the exact temperature over the water in between the measurements of the lasers, and so according to your logic, that still stands.
That is almost a smart argument. It's close, but not quite there. So the problem is that I have a gap in my knowledge. That doesn't mean that they have a gap in their knowledge. So the people that actually built the tow tank didn't have the gap in knowledge. I just have a gap in my knowledge.
So you haven't provided the methodology.
The experiment had a gap in their knowledge. The people doing the experiment, the laser test, had a gap in their knowledge, which does invalidate their experiment because they didn't account for
Not really. It doesn't really. You're assuming that if there's a massive temperature differential, then the light's going to be able to travel around the ball and hit the target.
Yeah, it is. When we account refraction in...
Yeah, no, we don't have the conditions required when you measure the temperature on both ends.
Sorry, sir.
Dude, I don't know why it's so hard to get, like...
We can get the conditions in the middle? Is that what you think?
I think you should get us the knowledge that you're gapping on, because that would be the thing that would validate your entire claim.
Yeah, like the length.
I don't need this to be 100% fundamental.
No, it's not, dude. Right now, it's an assertion.
A reference to a piece of evidence.
Look, listen, friend. Guys calculating the curve they should expect and then forcing that expected calculation into a piece of metal doesn't prove the Earth is curved.
Of course it does. The tow tank works. So that
holy frick, dude. No, let's be clear. Let's be clear, dude.
That's a logical fallacy, dude.
No, it's not. What logical fallacy is it?
It's called appeal to pragmatism. It works, therefore it's true.
I haven't heard that. Appeal to pragmatism.
Right. It also assumes...
You haven't even heard what your own argument is.
Correct. It also assumes that the variable and difference that they needed to account for would have made the object in question unusable had they not accounted for it. But when you look at the tolerances necessary in those machines, and you look at what the alleged curvature is over that distance, it's negligible, inconsequential, irrelevant.
So it doesn't seem to be that it's a pragmatic fallacy.
It is. You said it works. Therefore, the reasoning is correct. That was your claim that you just said to try to rebut me.
Well, no, it works because it physically exists. So a pragmatic fallacy would be something...
My truck... Oh, well, dude, my truck works. My truck works. Right? My truck works.
I believe X is true. Believing in X results in practical benefit. Results in practical.
No, dude.
Therefore, X is true.
Dude, no, that's not how it works. Here, let's put it properly. Hold on.
Consult my horoscope. Things always go wrong. So it seems like when there's actual like a physical thing, then the appeal to pragmatism is.
Dude, you're trying to say the tow tank works, therefore the Earth is curved. You're not trying to say the tow tank works.
Let me give an appropriate analogy. Epicycles work, therefore they're true. Epicycles work, therefore they're true. That's the actual physical situation. Epicycles, yeah.
What are they?
It's a Ptolemaic model of orbits.
Do they work?
Yeah, they work. Yeah, they work great. They work better than frickin' Newton's model or Kepler's model. Yeah.
Can you reference that?
Oh, sure can.
Spell M.
Never heard of epicycles? Jesus Christ, man.
No, I haven't.
Some elementary shit.
Do you speak any English?
Epicycle model.
Yeah, they use them in a planetarium when you go there. When you go to a planetarium, they project the planets and the stars on the ceiling, on the dome ceiling. They use epicycles. They don't use the heliocentric model to model. Just because you have a model that works doesn't make the model physically real or have some ultimate reality there. This shit is well known. It's not even an issue.
What do you mean by works? Do you mean as if we model something out, we get a result? Or do you mean as
and you got a result. Yeah.
Build things based on it or measure things based
on it? Yeah. That's called engineering. Yeah. It's awesome.
Yeah. What it's called is predictive evidence.
Okay. So
what they did is they predicted that the water would curve. They predicted in order to get their rail to match the water, they would have to make their rail curve. They then predicted that a string line would have to deviate at certain points by X amount in order to fit that curve prediction. And then it was all true. That's called science, buddy.
No. First of all, that's not called science.
I'm not seeing anywhere
that all would be like post-dictions. Those are all like post-dictions. Because they had to alter the string. I'm reading it right now.
No.
They had to adjust the string until it so-called aligned.
What part? Where's that?
I'm going to read it. A 0.33 millimeter dynamine fishing line was attached to one bespoke winch at each tail end. The line has a breaking point of about, that sounds precise, about 25 kilograms and very little stretching. Oh, that's scientific too, man. Very little stretching. It's not even like they have two things here that they didn't even quantify.
Sorry, you haven't validated your claim, mate. Go back to your claim.
Listen, I'm going to keep going. I'm going to keep going. Don't worry, man. There's more here. So, but I'm just saying, this does not sound like precision. Okay. Anyway, which allowed it to be pulled very tight and reduce the catenary effectively. A microscope was mounted on the rail to look down at the line and perform the adjustment with high precision. Right. So they adjusted the string until they got it to match
really
where they wanted.
That's really sad.
So this is your repeated thing I've been listening to over and over again. When you get cornered in this box, you start talking about us and how our argument is and how sad our argument is, and you start talking about us. The way we're talking, the way we're arguing with you. Shut the fuck up. You're here for round 3 to get knocked out, dude. This is like, Hearns versus Haggard. There was never fight 2 and 3.
Where'd they move the string?
Anyway, this is not a precision measurement. This is garbage, dude. Garbage.
Yeah, I'm referencing some experts that built something according to the curvature of the Earth, and it worked. What's wrong with that?
Yeah.
Are they lying? Do you think they're lying?
I think it's confirmation bias. That's what I think.
Okay, so they specifically machined and came up with a system to make the rail curve to fit what they thought the water would do, and it was correct. And you think that's confirmation bias? How does that work?
Yes, I do.
So if I was to think something like, no, like, if you just use like a base iron to make a camshaft, that'll be fine. Like, it's great. I believe that. Someone told me it had worked before because I used it in an old steam engine once. And then you do it and it fails because it's not the correct, metal to use.
Yeah, and? How is that analogous to this?
So confirmation bias failed in the practical, didn't it?
Yeah, because that's why engineering, you do things by trial and error.
No, you
right. So things are manufactured all the time that fail, break.
Engineering is doing things by trial.
It is.
That's the dumbest thing I've heard. Honestly.
Well, then you've never actually made anything. Have you ever made anything in a manufacturing process? Have you ever worked in any manufacturing environment?
Yeah, I've worked in a couple of factories. They're shitty jobs, but yeah.
No, an actual manufacturing environment where they actually engineer, design, and make the product, and then have samples, and then the samples are gone through tests, and then you have the production line, and you start making it in production, and then you have to have quality control because not even that is a perfect process. It's called trial and error.
I get all that. Yeah.
So you start with an idea, right? You maybe apply some models. And then you engineer some prototypes. Some of those prototypes will work. Some of them won't. Right? So if they could just do it by equations, then they should just be able to fill out the equations, do the math, start pumping out the products without ever testing them.
The one I worked in made fire-resistant suits for firemen. Right? Mm-hmm. And it was for firemen working with the army, so it was like armed personnel fire-resistant suits. And what they did is they got the known tolerances, so the fire-retarding capabilities of certain fabrics, and then they got their heat sink capabilities of other fabrics, okay?
Yeah.
They added all that in with the dimensions of a human being, and then they modeled that out so that any stitching would be covered, and then everything was cut, everything was manufactured, and they tested at the end to make sure that everything they'd done was correct. But everything they'd done was correct. They then updated it depending on user needs, but that fabric had known properties, and they
how did they know the properties?
That they
did they use equations or did they test the fabric? So they got the fabric secondhand from somebody.
Someone else did.
Exactly. So they got it from somewhere in that place that manufactured the fabric.
Steel, do you? The manufacturer tests the steel to make sure the grade is correct and then sends it to you.
Yeah, they have test samples. They test samples, right? So they manufacture fabric samples.
Engineers buy things of known properties. They don't test everything.
Yeah, it's known because they tested it to trial and error and figured that stuff out.
Yeah, a long time ago, and now they're known properties. So engineers can make things using those known properties, like the engineers.
Yeah, so they're just using trial and error.
They knew the known properties of that fishing line before they started.
Not within any certainty, obviously.
Yep.
About 25 kilograms with quote unquote very little stretching. Not the stretching was not quantified. The break point wasn't actually quantified.
And
it could listen.
And
the catenary curve that they calculated existed might not have existed.
How do you know that? You're just coming up with that. If they've had some monumental failure.
Because you think this is a precision, some sort of precision. Listen, because you think this is a precision measurement of curvature.
The precision in that document. How do you know they didn't have the precise properties of that string line and just vaguely referenced it because they couldn't be bothered going and looking it up again?
How do you know these people weren't fucking aliens from Mars and didn't just fucking throw a bunch of random words on the back of paper? I mean, come on, dude.
We've never seen aliens in existence, but we've seen people in existence. We've seen engineers in existence. We've seen the properties of certain string lines in existence.
We don't see curved bodies of water in existence.
We've seen that when engineers calculate as much stuff as possible and it all works, then it's reasonable to assume these engineers are competent, aren't they?
We don't see curved bodies of water in existence. Look, no, that's stupid.
Where, heretic, where? Is that all you got?
You're just assuming shit, right? You're just assuming shit, which is par for the course.
Yeah,
it doesn't shock me.
Induction. I know it's scary to you guys.
Yeah. Inference and induction. Yeah, great. Affirming the consequence.
Oh my God. Can you say it again? Inference and induction?
Yeah, inference and induction. Yeah.
What's inference?
Inductive logic is hinged on making inferences from observations. Is that not true? Is that not a true statement? Is that not a true statement? Yes or no?
You get, sorry, did you say inferences?
Yeah, dude, how come every time, like, see, the problem, one of your problems is you talk too much.
What you said properly.
You talk too much. Do you know how many times you have to say, I didn't hear you? Because you're fucking flapping your gums?
People. We're on Discord, mate.
Yeah, because you can't listen and talk at the same time. That's why you can't hear people.
Induction also doesn't lead to concrete conclusions. It only leads to strong or weak, potentials.
Well, he didn't even do that. He just assumed his conclusion in the first place.
Well, no, I didn't. I gave.
Yeah, you did.
So what I have
no,
is a
you
hypothesis,
didn't.
And
you already admitted
my
it.
My hypothesis is either
you assumed a curved water level. You matched some railings to the curved water level that you assumed, and then went, "Good, it's all curved." That's all you fucking did.
No, I didn't. What they did was they made the railing.
You're right. I misspoke. You didn't do that. That's what you think someone else did.
So we're at the point now of just muting me all the time? We're finally done? Do you want me to just go now? Are we done?
You can do whatever you want.
I can leave if you want. If you're just going to mute me anytime I'm halfway through a sentence.
Well, you can sit here and cry, or you can leave. I don't care.
We just told you that, basically that you're over talking. I tried to tell you what the problem was, why it's not a good thing. Because it means you're not listening, right? And we're just wasting our fucking time, which I'd rather not do, right? So
no, I was listening. I just think you're wrong. The reason I couldn't hear some people is because some people are low. So I'm trying to figure out who's talking, whose sound is low, so that I can turn them up so I can hear them better next time. Make sense?
Anyways, Linda, feel free to be a beta and leave if you want, but that wasn't what we were trying to do here.
Why would I be a beta if I left?
And you still haven't proven curvature or anything else. All the stuff you said is crap.
Why do you use the word prove?
I can't even read
evidence, which can never prove anything. It's called the problem of induction.
Trying to figure out why they need to compensate for curvature for this design.
Why
the rails must be aligned vertically to follow the curvature of the Earth. Vertically?
Vertically?
Yeah, the rails must be aligned vertically to follow the curvature of the Earth. Horizontally and in roll in Southampton, Saginaw, oriented a tank of 138 meters.
Yes, that's talking about
is about 0.6 millimeters.
That's talking about the rail, in this case, has little like jacks under it to move it up and down before they set it. So they have to be aligned vertically. Those jacks have to be aligned vertically so that the horizontal lines up with the horizontal curve of the water. What's wrong with that?
Doesn't seem necessary for what they're doing.
Why? They're trying to do
I'm reading it,
measurements of different hull shapes.
Well, do you know what uncertainty and precision is?
Yes.
Okay.
Uncertainty is an unknown, and precision is to the highest degree of measured known. So for this tow tank, they need to know if there's a deviation in the railing, because that deviation in the railing would cause it the hull of whatever thing they're testing to push further down onto the water, causing more drag and changing the results, or to go higher up over the water, which would reduce drag and ruin the results.
Okay, and if they didn't do it right, what would happen? Let's say they did all this process and they did something wrong and they didn't know about it and it's not in this document. What would happen?
What would happen would be that the boat, when they move it along the railing, would experience more drag in some spots than other spots, which would mean they would.
You mean so they're trying to model drag? So this is a tank that's trying to model drag,
amongst other things. Yeah.
I'm trying to figure out what the even purpose is. It just seems like just some nonsense.
I can answer the question.
If you get a boat and you get a hull design of that boat,
you're saying
some hull designs will go faster than others.
Brother, you're saying the same thing, so we're going to break it down to simplicity. All you're saying is that the rails must be parallel to the water surface. So this entire procedure is to make the rail parallel to the water.
Yep.
Yeah. That's all it is.
Of Earth curvature is in calculations. Thank you.
I couldn't hear you start that again because you were too upset and you cut out.
Well,
or they measured the curvature of the water level that they assumed.
All right, I'll say it
talking again while he was talking. So let me translate in normal speak.
Oh, I wasn't
normal
talking
speak
while he was talking, but I'm talking while you were talking because it's kind of sad to start off like that. So, Arden, do you want to just say what you said again? Because I couldn't hear you because you got too upset.
Yes.
See, once again, talking about how we're talking. You're being exposed. You're a chump, dude. You're just a chump. If you're going to talk about us, I'm going to talk about you. You're a chump.
Anyway, I'll validate my position, which is this. I'm driving a truck, which has axles, which make noise. And I have auditory feedback in my ears to my voice, where I increase the amplitude of my voice based on how much roid noise. Right? It's not that I'm upset. So again, you failed. But anyway, I'll say it very calmly. Yeah, perfect. Yeah, so here we go, friend. The entire methodology of the rails, the only thing that must be accomplished for the principle in question is the rails must be parallel to the water. It's all that has to be done.
I agree.
And all you need is a methodology that makes the rails parallel to the water, and all that is a distance from the top of the rail to the water's surface, and that's all they have to do. All that other methodology and including calculations for Earth curvature is superfluous.
Sure, if you look at the document, they didn't actually measure it off the water surface. If you were to look at Figure 4, you can see that tank isn't full. They're not measuring off it. And Figure 7 shows that they're using the microscope and the string line and the rail to check the deviation.
Yeah, so I'm not sure about this particular setup, but the other setup, which we already critiqued the last time a guy came in here with tow tanks, is they have a water channel next to the rail, and they use that water channel as the leveling channel. It's not the water in the channel.
Well, I'd love to hear about that. So which tow tank was that?
They're assuming the equipotential would be equivalent in both instances. So what they're doing is really, truly, they're just making the rail parallel with the water. That's it.
Yes.
You said so yourself. That's the ultimate goal, is that the rail is intended to keep the same drag line on the boat, continuous over its entire journey on the rail. Now, in order for that to be true, it must be what? Parallel with the water's surface. That's all they're attempting to do. No, which is assumed to be curved in your worldview.
No. Well, yeah, they assumed it to be curved. We gave them the prediction that if they set the rail at a certain curve, it would match the water, which came true. And predictive evidence is the only good evidence.
Listen, how are they making the curve on the rail, friend?
They get the string line and they...
The only way to curve the entire rail...
Based on their model.
What's the length of the line?
They adjust the rail, though. They adjusted the line.
Wait, no, they adjusted the rail. They didn't adjust the line. You were wrong about that. Remember, you read
so what I read was wrong.
They adjusted.
So what I read was wrong. That wasn't me freestyling. I was reading.
What you read didn't say they adjusted the line. If you look at Figure 7, you can see that they're set up on the rail where they have 2 pins and they have a microscope pointing at the string. Okay? So that means at any given point, they can look at their model and they can see how far should the pins be from the string at this point.
So they didn't measure it in between the 2 points, right? Just like the laser test?
Say again?
So they didn't measure between the 2 pins, right? Just like the laser test?
They did, yeah. They measured between 2 things.
Right, but I still haven't gotten the answer to 2 questions.
In between the 2 points, because so if you have a curve, then you need that like the hump in the middle of the curve. So you're supposed to have
That's what the string's for.
The strings to measure the hump.
Yeah. The string is a reference. It's completely horizontal reference, right? So from 2 points, it will be.
Yeah, he also claimed.
2 points.
Yeah, before you continue, we got a caveat before you continue that the allegation is that they. Go ahead.
Excuse me, Indio. I'm trying to listen to Arden right now.
Yeah, well, no. So they presuppose the.
I yielded the floor, brother.
Just wait, Indio. Arden.
Yeah. Great. Stop moderating our fucking chat, douche. Okay.
Yes, if you were paying attention.
They took the rail.
I yielded the floor to Indio.
I know. I don't know why you have to say it again. Stop humoring this clown, okay?
All right, my apologies.
So, listen, I'm not falling for the distractions, man. So they have this beam, right? This rail, and they can adjust the rail, and they pull the string. And so, what are they adjusting both at the same time until they're within the?
Why do you think they're adjusting the string?
Because they think the string has to be within a certain distance of the rail, right?
No, the string just has to be a reference, a horizontal reference.
But they don't know if the string's horizontal.
Yes, they do. If you get
how do they know that?
And you pull it taut between 2 points with very little catenary effect, it is a horizontal. It is a straight line.
How do you know there's very little catenary effect? That's what I'm asking you.
Because that's what they said.
But very little is also some. They're only seeing a small deviation, which is very little. So they're seeing the very little catenary curve. What are you talking about?
How do you know? You're assuming that because you're biased.
You just assumed that there's very little catenary curve. Your answer was because they said so.
Yeah.
Yeah. Let me ask a question.
What is the value for the catenary curve? And then, how did they measure this? Because you're going to have 2 inverted curves, right? You have the curved rail, and then you have the curved string. And the curves are opposite to each other. So one's curving down and one's curving up.
And it's a very...
Yeah, but I also want to know how long...
It's so hard they can't even measure the amount of catenary curve in the string.
That's not my problem. That's your problem.
Right, but also I just want to quick qualify.
Some catenary effect doesn't mean that catenary effect is enough to screw up their model.
They have to measure it, brother. Otherwise, they wouldn't know. By the way, also, you were asked... Hold on. It doesn't matter, dude. I just said they would have to. I'm trying to get to a different point.
The entire problem is that there's a catenary effect. Isn't that your entire problem at the moment?
Listen, the catenary effect is a constant in physics, bro. It can't be negated. Yeah,
but there are all sorts of problems that anything that you physically do, there's some form of tiny 0.000000001 problem in every single thing you do. But if it's not enough to screw up that thing, then who cares? It's like saying...
Right, so friend, for goodness sake, stop talking.
That thing can still work.
We all know that. Okay, what I want is the brass tacks. How long was the string? How was the... Shut the fuck up, kid.
Why?
Thanks.
All you're going to do is you're going to ask...
Because I'm trying to complete it, dude.
When the...
Alright, I'm just... Dude. These things matter. So stop frickin' sidelining. For goodness sakes. You were asked how they know it was horizontal. You just said they affixed it to 2 points. Being randomly affixed to 2 random points in free space doesn't prove that anything's horizontal. You then said... They got rid of the catenary. That's how they knew it was horizontal. But you didn't prove how they knew it was horizontal.
Didn't have a great
Dude, I'm speaking. Thank you. You then said that they got rid of the catenary problem somehow for whatever methodology they used, which you didn't quantify. You didn't give us the length of the string, so we can't even calculate any of these problems to even begin to say. So far, all this is a fanciful assertion with no data and no quantification to it.
Yeah, the engineers made it. It worked. They referenced they referenced the methodology they used. You just don't have the actual numbers in front of you, so therefore it's wrong. That makes no sense.
Dude, you haven't presented them. And your appeal, again, is just to the pragmatic at work. Dude, listen, the methodology they used got, let's just say for lack of a better term, it got the rail parallel with the water. Great.
Right.
What does that prove? Nothing. It just proves that the rail is pretty parallel to the water. That's it.
Pretty parallel?
Yes, because of the sentences that you just talked through, everybody, about error bars and all this other nonsense. You know it's not perfectly parallel. Good grief, dude.
So, Heretic, you said it's a pragmatic appeal again, but it isn't actually a pragmatic appeal.
It is. You said it works.
No, a pragmatic appeal would be for something unknown and unmeasurable.
What?
Where's the measurement?
Is for something unknown and unmeasurable, something abstract, like astrology work.
It is unknown. You already told us it was a gap in your knowledge, dude. You already told us the measurements that we needed were a gap in your knowledge, so they are unknown. And you don't have the measurements. Yeah, okay. How do you know? They don't know what they know.
You also admitted it was a gap in their knowledge because they didn't add it in there and have it nowhere presented. So.
Yeah, so let's link their engineering specs for this whole thing. Do you not understand that?
Right, but the other one that we did, bro.
Find a flaw that you can exploit in this when you guys don't have a single measurement of straight. Like, I gave a glaring flaw in your laser test.
You didn't. Actually, you just showed your ignorance. You actually just showed your ignorance.
Did I, Indio? Do you want to talk about that? Do you want to? If I get 2 points across a bay and I just measure what point A and point B's temperature are, does that tell me the refractive index across the bay? 1, 2, 3.
No, it does not tell you the refractive index across the bay.
It could,
because
possibility.
You could explain how it could? You could apply modeling and you could assume it.
They didn't apply modeling though.
Yeah, why would you?
So they didn't calculate a value?
That there is refraction. You need to establish that those models are correct.
But you can't establish if there's refraction unless you measure a difference across the bay, can you?
They did. They did have 2 meteorological stations at each end.
Yes, of course there'd be something different, Drace, you fucking idiot.
So you do know that
the idiot
2 meteorological stations, right?
Yes. And they said meteorological station 1 and meteorological station 2 show X, but all that distance in between, they didn't measure any points on that and then map out the refractive index. Refraction doesn't happen between point A and point B. It happens the entire way in between. As any sort of change.
No, that's not how refraction works. That's not how refraction works.
Of course it does.
No.
Light goes from one dense medium to another dense medium. All that has to be is a change in temperature, pressure, or humidity of that air.
No, it's not. It's called optical density. It's not just the density of the medium.
We covered this with him before. Yeah, we've been over this optical density. He was furiously Googling or something.
You guys say it's optical density. Optical density can be changed by factors like temperature, the density.
Yeah, it can. But you also require the correct boundary conditions to those temperature gradients to be able to refract things, and you don't have those conditions all the time. And it also it depends on those angles and the optical gradients.
So you know what,
the light can go up and down.
So you know what, ISIL, not only did they horizontally pan it, they vertically panned the laser, and on top of that, they did it twice. They did it twice, 3 weeks apart, and they got the same result. So when they just have
what does that mean?
So they have to have the same magical refraction conditions, the same 2-3 weeks apart.
And in different directions at different ranges. They didn't just horizontally pan the laser. They panned the laser horizontally.
Seems like they had different outcomes.
See, here you go again.
I'm speaking, brother. Okay.
AI, please.
Yes. They panned the laser to targets at different ranges. So, for example, in the 25-mile shot, the 25 miles was the final target, but they panned it through like a 4-mile target, a 14-mile target, etc.
And this was done 3 weeks
it
apart.
Seems like they've got different. It seems
the firing line is hot.
It
seems like they have different what?
They have different measurements for every single laser test that they did.
What does that mean?
Well, considering
different measurements of what?
They say refraction exists. Yeah. And they say that the laser is hitting different points, but it's just within the tolerance that they set based on the refraction that they think, to fit a flat Earth model, right?
No, they're tested. They tested the WGS 84, and it's outside those values by 2 orders of magnitude.
Because they didn't look at the refractive index between the 2 points. So the 2-week change would cause a small change in refraction in the refractive index, right? It wouldn't be
okay. So how much refraction does there have to be to get the result they got?
Well, we could look at that if you'd like.
Yeah, let's look at that. Give us the model that can make that prediction.
Let me know when you're done with
the Bislan Advanced Earth Curve Calculator.
That doesn't. First of all, there's no predictions in that. I said a model that makes predictions, not post-diction.
Yeah, so the Walter Bislan Advanced Earth.
Yeah, those are post-dictions. I want predictions.
Observation data, and then you just change the refractive index.
Yeah, that's a post-diction. That's not a prediction.
I just.
Yeah, hold on.
For a second. Let me know when you're done with this point so I can jump in, because I wanted to ask him a question. But I want to mute him.
Yeah, but I want to. No, don't unmute him.
Amount of time, Miggy. I'll just yield for you.
Yeah, I will let AI, because I don't know. You guys were in the point right now, but I don't know. AI.
Yeah, we can wrap it up very quick. So what he did there is he has an ex post hoc solution, because he's going to go to this calculator and just change the dial until the dial fits the observation, which he already said he will do, which is no observation can debunk the globe, because you can always input refraction to be sufficient ex post hoc, which is not proper reasoning or proper anything. All right,
and basically the calculator doesn't simulate anything. If you look at the Black Swan so-called simulation, okay, if you look at the rays, they invert. So the image that you should be shown should be half inverted. But he doesn't show that, right? So all he's doing is adjusting pixels up or down, but never adjust the orientation. So that calculator doesn't simulate anything.
Well, it does simulate one thing, so let me finish up with this, is that it simulates an increase in the radius of the Earth to lower the Sagittar via the circle segment formula. In other words, it models a lower hump between point A and point B, which means it's effectively flattening out the Earth to account for observations that debunk the globe, conceding that the Earth looks flat. I yield.
Okay. I'm going to unmute him. Dogs, if you can hear me, I just need to ask you a question before you go on. Or maybe you just want to respond real quick so I can ask you?
Yeah, it'll only take me 2 seconds to respond.
Yeah, go ahead.
The problem is what you said about Walter Bislan's Earth Curve Calculator flattening out the Earth is that it flattens out the apparent geometric horizon, not the actual one. You get that? And there's no problem with a post hoc falsification of an experiment. The problem is if you have a positive claim and you want evidence for that positive claim, you then need to make it predictive. So I'm not saying the Earth is a curve, because I can post hoc use refraction to account for a flat Earth like experiment.
Man, I want to respond, but go ahead, Miggy. I'll bite my tongue till later.
Yeah, we'll just, I guess you can respond. I just need to ask you maybe 2 questions. Can we know 100% sure that the Earth is a globe in any way?
No.
Okay, second question. Has anyone directly measured surface curvature?
Yes.
Okay, can you tell me who?
Transcontinental arc, the parallel.
Who? No, that's not what I'm asking. I'm saying who directly measured it. Was there what persons were there or people? Was there a group of people?
I could find the people that did it, but
No, I know that, but I'm saying, do you know?
That's called a genetic fallacy, so it doesn't really matter.
No, I'm asking you a question though. Either you know or you don't, right?
Not off the top of my head, no.
Okay, so you don't know. Yes, it's a problem. It's definitely a problem because the whole topic and the debate surrounds the information of a baseline of knowledge that you do not have, which right now currently seems to be stemming from.
How does the knowledge of who made the?
Okay, so I'm trying to tell you, unless you want to interrupt me and then form your own conclusion. It's up to you. So the knowledge base of what you have right now.
You lagged there, so I interrupted while you were lagging.
Oh, all right. So, can you hear me now? Hello? Can you guys hear me?
Yes.
Okay. Yep. So basically,
go ahead.
Okay, so the knowledge base that you have right now is built on derivative topics that's surrounding like a giant puzzle piece that you're trying to put together. They're like all these little clues are going to equal to like curvature. That's what I've been listening to for the past, I don't know, hour and a half that you've been in here. That's what it sounds like to me. You have a lot of evidences that are going to equal to your answer. Is that correct?
That is correct. What's wrong with that?
Because it's not one single direct measurement of the thing in question. So let's put it this way. I'm just going to give you an analogy, right? Like the ones you've been using. So basically, if I have a basketball and I tell you it's a cube, you would be telling me that it's incorrect. And I would be saying, how? You said, because we can directly measure this thing, which it turns out it's going to be a sphere with a radius, diameter, and circumference. And you can show me how in math, also in principle, how this actually operates in reality. So if I was to tell you to do the same with the geometric shape that you're actually standing on, it would not be the same. And I would ask you why? Because it's the same thing in reality, something tangible, something you can actually look at, and you can actually apply maths and then directly measure the thing that you're in question, right? So in this instance, it feels like it's a bit more obscure, and all these little clues that you're talking about don't seem to add to the single direct understanding that we know that the Earth is curving with the set rate that they're telling us with the diameter and radius. So what we're doing right now is we're going round and round and arguing about derivative topics, never getting to the underlying premise that the Earth is indeed measured curvature, because we have all the metrics, as you may or may not know. They're made public to everybody, so we can pull those up and we know what they are. So what I'm saying is that it's a fruitless endeavor that you're on right now, this quest to actually try to prove the thing that you're actually trying to prove, but without proving it directly, but indirectly. And so maybe to you that makes sense, but to everybody here, knowledge works. I know, but I'm saying, but to everybody here, it makes more sense to directly measure the thing in question, and that hasn't been done.
Can you directly measure something that is as large as the Earth?
Yes, absolutely. With the variable. Listen, because I'm going to tell you.
Can you do it the same as a basketball in your hand?
Yes, absolutely.
No, you can't. You can't, because you're big and you can have bigger things to use as measuring tools for that Earth, right? For that basketball, sorry. But for the Earth, you can only measure a small patch of the Earth at a time.
No, that's the thing, though. How did we do it in the first place? Because we have these metrics.
Transcontinental arc, the parallel.
Okay, so is that how we derive the metrics of the Earth? Yes or no?
Well, no. What we did is we have tested it many different ways. Some haven't been exclusive to a globe Earth. Some could be experienced on a flat Earth, but we have then done some that are conclusively for a globe Earth. Did you hear what I just said, or did you start talking after you'd rambled for like 4 minutes?
We have the metrics. You don't want to look at the metrics.
Do you hear what I just said? Do you hear what I just said, buddy?
No, because it's not the actual direct measurement of the Earth's curvature by which we have.
Do you have a direct measurement of flat Earth? Yes or no?
I don't need to directly measure something.
Exactly. You're a fucking hypocrite.
Okay, so now you're resulting to insults because you're losing. You don't know how to provide evidence for the direct measurement of the Earth's curvature, so you want to spiral.
Transcontinental arc of the parallel. What's wrong with that?
Is this your out? Because it's not directly measuring the surface curvature. That's why.
It is.
And I asked you, is it? You said no. You conceded. That's great.
No, it is. Transcontinental arc the parallel directly measures the curvature of the Earth.
No, it doesn't.
It does.
Does it do we derive the metrics of the Earth's size from that?
Yes.
Show me where.
Great. I will link you the document.
It's a document that you didn't read.
Yeah, the one I did read that you didn't understand. You thought that
dude, you can listen.
That they listed as direct measurements. You thought they'd already applied some form of transformation.
They did.
Read page 47 this time.
They did.
they didn't, Indio. Remember? You linked it to me and you read it, and it said that they had put the data in and then they put the calculation.
Sorry,
it's called a horizontal reduction.
So,
right?
like, listen, I asked him for direct measurement. He said no. Now he's saying yes. He's going back and contradicting himself. But what he's going to post, because we've all seen this document, right? This PDF. I think is it page 19? Is it on the 4th paragraph? He's going to be astounded to know that it's not. They didn't directly measure anything. They actually pulled it out the Clark spheroid model. That's what they're using. So they didn't measure the curvature of the Earth.
He's denying that that's what they did.
Right, but that's what it directly says on the PDF that he's probably going to post if he hasn't posted it already.
He's denying it means that.
This dude is infamous, though.
His own meaning.
He's infamous for denying his own references. That's all he does here.
So the thing that I asked him were 2 questions. Can we know if the Earth is measured to have curvature? He's for 100%. Like, can we know that? He said no. Second one was that has it ever been directly measured? And the answer was still no. It was because he's trying to use all these derivative topics to ruffle feathers and try to make it seem like he has a point when he does not. And he starts to get angry and starts to put out insults because he doesn't have an answer. But that's all I wanted to say, just to expose him that he doesn't have an answer, and he wants to dance around it. That's all he knows. And that's all I have to say. I yield the floor.
I did notice he had a lot of direct, pointed personal insults. Now, I did swear at him to say shut up because he was constantly over-talking and through-talking.
Okay, can I talk about Mickey for a second? And how he started off with a genetic fallacy?
We'll talk about him, or do you want to talk about the arguments?
No, his argument. His argument was a genetic fallacy. His argument was, I didn't know who did the measurement, so therefore the measurement is wrong.
That's not a genetic fallacy.
No, he was talking about you. He wasn't talking about the argument.
I don't know who measured the transcontinental.
No, he's pointing out that you have a belief. That's what he was pointing out.
Yeah, you just have a belief.
That's exactly how he started his argument. Is that how you started your argument? Because I wrote it down.
Yeah, that's okay. If you think about his first question,
I said no because we can't be sure of anything. It's basic epistemology. If you knew anything about knowledge, you'd know that.
Oh my goodness, dude!
You said that because I don't know who did it, I'm lacking some knowledge that makes that an actual like a good argument. When that's
that was your interpretation, but he never said any of those words.
He specifically said I was lacking some fundamental.
Yeah, that's right, but he didn't
sources that would make my sources incorrect.
No, you're adding that yourself. The incorrect part, you're adding that. He never said that part.
Okay, so for everything I've argued so far, what have I done that have made my arguments incorrect?
Okay. He wasn't arguing against your arguments. He was illustrating the fact that you have a belief.
He was using a genetic fallacy, yeah.
No, dude, what don't you understand? He was just illustrating the fact that your claims about whatever measurements exist out there, the results of which that you don't actually know are just a belief. Oh my god, dude.
Anyway,
it's about you, dude. This isn't about the measurements. It's about you. Are you like some weird narcissist?
Page 19 of the Arc of the Parallel. Isn't that great?
Dude, just listen. Before you read that, you need to specifically rebut the claim that they pulled that stuff off of that model.
Well, how about this? I can get right to the heart of this. Why do they use a reference ellipse? Why do they use a reference ellipsoid in the first place? Why is this even used? They're just measuring curvature.
We have previous information that tells us the Earth is a sphere. So based on that previous information, people now assume it because it makes sense to do so.
But why is it used in anywhere in any calculation ever? Why do they need it? Why is it necessary?
We have previous evidence that the Earth is a globe.
Okay, that's awesome. But why do they need it? You're not answering the question. Why do they need it in the equations? Why does it exist?
For the
why not just use the raw measurements, right, and then just come up with it like that? Why use the measurements and reduce them to an ellipsoid? Why are they doing that?
They have the raw measurements and they have the ellipsoid measurements.
Okay, so why are they reducing their raw measurements to the ellipsoid surface, the sea level? Why are they doing that?
Because they want to fit the measurements that they've made onto one larger, grander set of maps. or measurements.
Okay, that are based upon old measurements. Were they reduced to another ellipsoid?
No idea what you're talking about.
So you just said the ellipsoid is based upon measurement.
Let's look at it this way, buddy.
Don't overtalk me because you know you're fucked now. You're fucked and you know it, dude. Yep, that's right. You're fucked and you know it. You're fucked and you know it, dude. Sorry. You know you're fucked. That's why you're trying to fucking rabble-rouse right now. Listen, you said the ellipsoid's based upon some previous measurements. So these new measurements, arc of the triangulation, they reduce the measurements to the horizontal directions to the surface of this Clark ellipsoid. Where'd they get the Clark ellipsoid from? And when they took those measurements, did they reduce it to some other ellipsoid? How far back does it go?
Assumption upon assumption upon assumption.
To the first measurement of the radius of the Earth, you fucking moron.
When was that?
Do you
When was
understand
that?
how stupid you are?
When was
that?
I don't know. Maybe I don't.
Oh, you don't know.
That's probably prior to Eratosthenes, but Eratosthenes did the first one, and then we worked out
sorry, I missed that. I missed
was actually
that.
correct using different styles
He's
of
going to talk about
measurement.
Al-Biruni?
We've done it
Yeah, I
dozens of
missed that.
different ways. How do you guys not understand?
When was this measurement, dude?
Okay, the radius of the Earth's never been measured and can't even be measured in your paradigm.
His whole argument is based on he doesn't know. That's it. I've been saying I don't know this whole time, dogs.
You blow your father with
That's
that?
embarrassing, bro.
Look, you know what the answer is.
Look. Should we just
It's
read
embarrassing. It's embarrassing. You're embarrassing yourself, dogs.
Yeah, you're so emotional, man. What you talking about? AI's emotions?
Go back and learn some more.
Let's have a good cry.
Yeah, I got a shoulder you can cry on if you want. Go back to McToon and go get some more information from him because you're not up to date, bro. This is weak sauce, bro.
You guys haven't given a single argument for flat Earth.
Bro. You don't know about I don't know. I don't know. Are you 100% sure? No, we can never be. Well, you don't know anything, bro.
Dude, it's not.
Anyone that knows about epistemology knows you can't be 100% sure about anything except.
Well, then you don't know the Earth. Thank you for admitting that.
Yeah,
and
it's nonsense. It's provisional knowledge. It's knowledge that isn't 100% complete, but it is still knowledge. You have two competing hypotheses, and one has over 50% probability of being correct based on predictive evidence, then you should go with the hypothesis that has a greater predictive evidence. This is epistemology 101. It's fallibilism.
Dude, you just don't know.
That's your lack of fundamental knowledge about knowledge is the problem. That's why you're all fucking flat earthers, because you're too dumb to understand.
You don't know anything, dude. I love it. I love that you don't know. Please.
What he basically said is that if
tell me why fallibilism is incorrect.
If something has a greater than 50% probability and you have no other alternatives, you should accept it as true until something new comes along. Then it becomes false. Hooray.
Great. That's great. So give me something new that comes along that disproves the globe.
You don't know. That's all. That's
Nothing's
all,
come along that proves the globe.
That's all, folks.
I just gave you like 4 different things, didn't I?
No.
Yeah, 4 different things that don't prove.
Yeah, 4 different things that you don't understand.
From towers is one. Yeah.
No, it isn't. No, it isn't, dude. Towers, bridge towers are not evidence of curvature. You're a clown, dude.
Go try to make.
We need to find some way to disprove these things instead of just saying.
You haven't proved it in the first instance, you weirdo.
And I didn't add in this specific number.
You haven't proved it in the first instance, dogs. So don't even be saying that you got all this evidence. You got shit, bro. You ain't proved nothing.
Can you tell me what's
you're
wrong with the
saying that I don't know. I don't know. I don't know. That's what you said, bro.
We got to do that again.
If you read that document, there's not enough information in that document to make an evaluation. And
but
you
that doesn't
claim
mean
that
it's wrong, does it? The experts, the people that built it, say
the experts, exactly. Exactly. You just said it all. Your actual true epistemology, the experts.
Oh, by the way,
you talk all highfalutin.
By the way, that's a genetic fallacy. The experts. It comes from the experts, therefore it's true. It's a genetic fallacy.
A genetic fallacy would be because they are the people that did it, it must be correct. But the problem is that they did it correctly using the methodology that they chose.
Are you keep saying I don't know, dogs? We're used to you saying that already in here, so just keep saying I don't know. That'll win an argument anytime.
What's the correct methodology? How do you know the methodology is correct? Give us the methodology then.
I don't have to. The toe tank works.
Okay, so you don't know the methodology, but you know it's the correct methodology. How does that work?
The same fallacy. This is crazy.
The methodology is correct.
Works, dude.
The toe tank works.
And because the experts worked on it, and it works.
Because the rail and the...
So nothing to do with their methodology, just the experts, exactly like these guys just said. Cool.
No, the thing itself, the toe tank works. That's evidence that the engineering works.
Yeah,
it works because the thing works. That's how engineers work, you idiots. Do you not understand this?
Yeah. So I got a PDF from an engineer from Australia that says just because it... Oh, do you want me to... Okay. Now, hold on.
I read your last PDF. Do you remember what happened there?
No, I don't. Well, you read what PDF?
Big failure in them not calculating refraction across a body of water?
Yeah, they don't. They don't need to because it's an unproven quantity. Gee, that's why I asked you. Let's actually go back to that.
Wait, is this a YouTube video?
Let's go back to that
video. This is the calculus they won't teach.
Listen, don't mute him anymore. Let him talk. Right? Don't interrupt me. We're gonna have a real interchange. Fucking interrupt me, I'm just gonna kick you the fuck out of here. Okay? It's gonna be like that. So check this out. I asked you, what model for refraction should we use to make predictions? You are aware that there are probably a dozen to maybe 24 models of refraction going back 150 years. Which model should we use that makes predictions? Which one?
Snell's law.
Snell's law doesn't work.
Why?
Because it doesn't preserve the angles.
It doesn't preserve the angles. That's the whole point of refraction. Refraction is the angles changing.
Okay, so in a gradient index medium, you can't use Snell's law because the angles are not preserved. Okay, so hold on, I'm describing.
The angles are not preserved. Can you explain what that means? Because the angles aren't meant to be preserved. The angle is meant to go from A medium to B medium. The angle is to change the inference angle.
Yes, that's right.
C medium is meant to change again. Then from C to D, it's meant to change again. Then from D to E, it's meant to change again. So at what point?
Sine theta is a conserved quantity in Snell's law.
Say again.
Right.
I didn't hear
Sine theta, the angle is a conserved quantity. Okay. So the angle of incidence and the angle of refraction have to sum to 180 degrees. Right? Because they have to be normal.
Sine theta has to be 180 degrees.
The sum of the angles. The sum of the angle of incidence to the medium's interface, right?
Yeah.
And the angle of refraction have to sum to 180 degrees.
Okay, and?
Okay, so in a gradient index medium, that's not the case. If you apply Fermat's principle, I just posted a PDF that runs through the mathematics. I don't expect you to go through it now.
Live stream text?
Yes, right? I even posted the PDF, right? So it says sine theta conserved along the light path. It goes on. Snell's law states that the quantity sine theta is not changed in the refraction of light passing from one medium to the other. We acquire whether this is true in a general case where the speed of light varies continuously within a medium. That is a gradient index medium. Right? So you have to apply Fermat's principle, right? The principle of least time. So you understand that. Final result of these exercises is that, contrary to initial expectations, the answer to the question in the title is negative. So there's problems with using Snell's law and a freaking on like some gradient index medium because you would end up having weird ducting, weird reflections, right? So if you modeled, right? So a medium with n number of indexes of refraction mediums. How many freaking layers are you going to use, right? So what you could end up happening is the light being trapped within one of these layers and never exiting, especially if the light ever ends up going horizontal. So if it ever ends up going horizontal, it's never going to transition some barrier, right? Some interface. So if you look at Andrew Thomas Young's website, he admits this, that results in a singularity if you use Snell's law, right? If you use Snell's law and the Earth is flat, right, and you have a medium at that level, so 6 feet, right, and you even have a gradient, right? You can even have a temperature gradient. That light, if it's horizontal, will never transition into any other refractive index medium because it's horizontal over a flat plane. So if you model out mathematically, yeah, it'll just go on forever. Right? The only reason you all say there's bending light, right, is because you have a curving gradient. I'm not gish galloping. Just because you can't comprehend what's being said because this is above your pay grade ain't my problem. That's your problem.
Well, I'm reading through this and I'm not seeing the part where they conclude. So what page is it where they conclude?
The conclusion? Scroll down.
Yeah.
The conclusion's literally in the abstract. You don't even have to read the conclusion. You can scroll down to it.
So in the introduction.
So you see, you've never read actually any scientific material, so this is just like fucking Chinese to you.
Well, the conclusion is usually...
I've been reading this shit for 20 years.
It's in the abstract.
The conclusion is in the abstract. The answer to the question in the title is negative. Is sine theta conserved along the light path? That means, says, Snell's law states that the quantity and sine theta is unchanged in the refraction of light. Is sine theta conserved along the light path? The answer to the title is negative. The answer is in the abstract. They don't use Snell's law to model in physics gradient index medium. Abstract. I posted it literally in the chat.
It also provides.
Look. The
final results of the exercise is that, contrary to an initial expectation.
Let me ask you this: does Walter Bisgund's simulator use Snell's law?
Yeah.
No, it doesn't. It uses Fermat's principle.
Okay, if he uses Fermat's principle, who cares?
Okay, so does Mick West.
What's the difference? What's the applicable difference between the two?
Is that there's no boundary
in Fermat's principle.
Yeah, there's no boundary. You integrate over the light path basically.
No. Yeah.
If you use the calculus of variations of integrate over the light path, whereas one is just simply algebraic or trigonometric, if you want.
And
that they're not mathematically equivalent, dude.
They are mathematically equivalent. The outcomes are still generally the same.
No, Snell's law is a special case of Fermat's principle.
They're still
where you have a well-defined deity. No, they're not.
Yes.
Snell's law is a special case, right? Snell's law is a special case where you have two well-defined mediums with a well-defined boundary.
Snell's law and Fermat's principle, would they be roughly equivalent?
In one case, where you have homogeneous, a medium where you have two mediums with different refractive index that are homogeneous, isotropic, and have a well-defined boundary. That special case, that's what it models. Which is great for designing lenses. Right? You can use the thin lens equation, no problem. Easy peasy. Then you still get to the engineering.
That's principle which states the light travels the path which takes the least time. By taking the derivative of the optical path length, the stationary point is found, giving the path taken by the light. And there are situations of light violating Fermat's principle by not taking the least time path, as in reflection or a spherical mirror. In a classic analogy, the area of lower refractive index is replaced by a beach, the area of higher refractive index by the sea. And the fastest way for a rescuer on the beach to get to the drowning person in the sea is to run along the path that follows Snell's law.
Yeah, because you have a well-defined boundary. Sand in the water. You go one speed over the sand and another speed over the water. So you want to find the path which is the most efficient to reach the person. Well, the principle of least time. Which one takes you the least time? Should you run through the sand more? Should you freaking swim more? Which one should you do?
Great. So they both use the principle of least time.
Fermat's principle, or Snell's law, is a special case of Fermat's principle.
Does, right? Okay, great. So why doesn't Snell's law work?
I told you, because it's a gradient. So now you have the sand, right? So the sand is continuously varying. In the water, your speed through the water is also continuously varying. Actually, there is no sand in no water because there's no well-defined boundary. It's just all sand. And your velocity through any given point in the sand, like at point, There's 0.0, 0.1, 0.2, 0.3, 0.4, 0.5, but there's a continuum. It's a continuous change. It's a continuous change, right? It's not a discrete change, like at a boundary, which is Snell's law.
Why is that a problem? So think about it like this time. You have X speed on sand, X and Y speed on water, and then you replace that water, and you have the speed across just sand being equivalent to the average speed between X and Y. And all it is just
I don't know how to explain this to you. Like if you don't understand basic mathematics, I just don't know how to explain it to you.
Well, I just explained to you what Snell and Fermat's law, the difference in the principles. One says you go from X to Y, and the other one says that there is a gradual change between X and Y. But if they both end up with very, very similar end results based on, the different optical
do they end up with similar results
of the mediums? Yeah.
Yeah, where's your evidence for that, dude? Like, seriously.
The paper you cited. They only found very, very small deviations using different calculations. In your paper that you cited.
Well,
every FLIRF paper disagrees with them.
What did you say?
Every FLIRF citation disagrees with
Dude,
them.
okay, you just said that there's a difference. Previously, you said they were the same. Okay, doesn't disagree with me. It disagrees with you. That's a crazy projection. Now it's close enough. Before you were saying it was the same.
I'm waiting for evidence that it isn't. Can you tell me why Snell's law wouldn't work across a lake?
Okay, because it's not a well-defined boundary. It's a single medium, so they have to.
You can take all the different mediums, and it's not a single medium because the optical densities changes depending on the temperature and the amount of air, the amount of water in the air, and the density of the air and the pressure in the air. So you can.
So tell me, how in reality, how would you model this out? How would you model this out? This gradient, right? This air gradient. How would you model this out?
I don't know. I don't have enough knowledge in maths for that, but I understand the concept.
Yeah, So you would have to use an infinite amount of
to B density or X density to Y density.
How many layers do you need?
Is that there is a gradual change between A density and B density. That's all it is.
How many layers until you approximate Fermat's law?
I don't know. I don't care. But that doesn't matter.
I know you don't care.
And this is amazing. This is amazing. You're doing a reification.
Yeah, now you're going to talk about me again. How predictable.
You're doing a reification fallacy.
No one is reifying it. I'm asking you. You say refraction exists. I'm looking for the evidence that it exists. I'm looking for the model that makes
mathematical
so that we can.
Is it something that exists in reality?
Refraction as a general phenomenon exists. Refraction bending light around the curve of the Earth. Does that exist? That's what we want to determine. Does that exist? What is the evidence for it?
What is the boundary in Snell's law? Does that reference something actual? Like an actual boundary? Or does it reference a mathematical?
Yes, it's an actual fucking boundary. Yes. No, it's where one medium becomes another medium. The atoms on one side is...
I've ever heard. It doesn't.
Oh, so water. Please don't. I'm asking you, please. I want to finish this. He's going to try and get off it. I'm not letting him get off of it.
Snell's law calculates the optical density of A and the optical density of B, and then it arbitrarily pops in a boundary between them.
Where do you think they would pop in that boundary?
What?
At the end of A, at the spatial end of A, and at the spatial beginning of B? Do you think that's where the boundary is? So if you have two substances, one's water and one's glass, the water's not the glass, and the glass is not the water, and where they meet is what we call the boundary.
They can both be water with two different optical densities.
So water can be water, and glass can be water and glass at the same time?
No. Indio, listen to me, okay? You can have air, just air, but if the optical density of air is different at 2 points, in Snell's law, you'll take those 2 points of measured optical density, so the different temperature and pressure, and you will put a boundary in the middle of that calculation. And that boundary calculates the deviation The refraction.
That's why I asked you how many layers, dude.
Going from A to B. Whereas in Fermat's, it will be a gradual change. It won't be a defined boundary they put into the calculation. It will be between A and B, there is this amount of change, not it changes at a defined boundary, okay? It's all abstract, it's all mathematical, and it's called a reification fallacy when you say that there's an actual boundary in spatial reality.
No, what I said was there is a continuous change in Fermat's principle, and you just made my argument. Thanks you very much. Snell's law. Snell's law has a boundary. Snell's law has a boundary.
I've ever.
Yeah, dude. Snell's law. Oh my God, the fucking spiral. Snell's law has a boundary. You said that you can make an arbitrary boundary. Where do we make that boundary? How many boundaries? That's why I asked you how many layers. You didn't even understand what that was talking about. Like, how would you model this? How many layers do you have to do? If I take 6 feet of freaking air, right? How many layers of Snell's law of different refraction index to model this gradient do I use? Do I use 10,000? Do I use 1,000,000? Do I use 1,000,000,000,000? Do I use an infinite amount? Right? When we use an infinite amount, well, oh my God, that's fucking calculus. And we use a continuum. And look, the continuum's more accurate than the so-called simulation of boundaries. I don't know why you don't understand this. Oh, because you don't know anything about mathematics. But your whole idea of refraction is based upon mathematical models, which don't work in reality, which make no predictions in reality. That's why I'm going to ask you again. I know someone muted you. Give me the model of refraction that makes accurate predictions that we can test, so that we know which one to use, so that when we make our post hoc claim, we can be using a model which has some predictive power. You even said we need predictive power to tell us what's likely true. Give us the model with predictive power.
Both.
Give me the exact model with predictive power.
Both.
Okay, so those are models. How are they tested?
I can find some journal articles if you'd like me to.
Yeah, I'm sure I've read them all.
Awesome. But are you willing to admit that the boundary is just what they put in? Like it's the maths that they add in to say that there is a defined...
They don't use Snell's law for a gradient, you clown.
A defined point between the refractive index of A and the refractive index of B, right? So all they've done is they've said there has to be a boundary here instead of it being a gradual change.
Okay.
No. You saying that exists in reality is bullshit.
No, when they model it, listen, when they model it in reality, right? Like if they model it between glass and water, they'll use Snell's law. But if they have a gradient, they're not going to use Snell's law. So when I say the Snell's law is an actual boundary, that's what they're modeling. They're modeling an actual boundary. They're not going to use it in a situation you're talking about. They're not going to use it for a gradient index medium. They're just not going to use it. So it's like,
why not use it? If it's easier, because Snell's law is
because it's inaccurate.
Principle, isn't it?
Because it's inaccurate.
To what percentage? To what percentage?
It probably depends on the application.
Oh, okay. So we can use Snell's law if we want, say, a couple of percentage points of accuracy, and then Fermat's if we want, say, a couple more points of accuracy. It's the same with Newton's and Einstein's, isn't it?
Well, it depends on the distance, right? So it depends on how long the light is within the medium, right? So that's the defining factor. How long the light is inside the gradient versus, or how many layers you model. So there's all different, depends on your model, right? So that you could probably make a situational Snell's law model and use Fermat's principle and get them fairly correct, probably for good enough for practical purposes, and make it quote unquote work. Right, but it's not what's used in the common practice. They just use Fermat's principle because it's more accurate. That's just what they do.
So they both would work. One's just more accurate.
But the fact of the matter is, you can use Snell's law. You can use whatever the fuck you want.
You thought that this boundary was a physical boundary. You fucking goose.
No, listen, in the use that they model it, it is. Yeah, in the use that they model it, it is. Whether you actually use Snell's law to model something,
it's real. When they model it, it's an actual boundary.
No, listen, they don't model gradients using Snell's law. Only dumbass fucking anti-flat earthers use it for that. That's what I'm trying to tell you. Only you fuck clowns use it for that. Nobody uses this. If you go read all the literature, no one uses Snell's law for this shit. Nobody. Not a fucking person. Only Dunning-Kruger.
Does it still work? Does it still work? Does it still work?
No.
Why? What's the percentage difference? How many decimal points are different?
I just told you. I already answered that question. Depends on the application.
You don't know. Replication fallacy, and you don't know, and you're trying to lecture me about the maths. At least I was big enough.
No. Listen, I told you the situation. It depends. It depends on the situation. It depends on what you're modeling. The error depends on what you're modeling. If you're modeling how long light's in fucking 1 millimeter of a gradient, dude. Yeah, they're going to be almost identical. But if you're modeling how far, like if it's going through fucking 1 trillion miles of air, that's something else. You're going to it depends. It depends on the application.
I think we're done with this now.
And no, you're going to give me the predictive model. Dude. You're just going to give it to me because we want to know when we do our post hoc, ad hoc bullshit at the end, right? So we can't falsify the globe. I want to know what model we have to apply.
You're obviously too
I want to know what model, dude. I want the evidence. No, I want the evidence for your foregone conclusion. I just want the evidence. That's all I'm asking for. What's the evidence, dude? What's the evidence? What's the evidence that any of these models work? What's the evidence that that light is bending around the curve? What model predicts that? And then that model has been validated by observation.
Great. I'm looking up
really simple.
Theoretical and experimental study of refractive indices of water, acetone, nitrile, and salt systems.
Yeah, so I'm talking about terrestrial refraction.
They calculated the refraction.
I'm talking about terrestrial refraction. This thing that's supposed to be like bending around the curve, making everything look flat.
If you apply it to the surface of the Earth. No, these are physical constants, buddy. Do you know what a physical constant is?
Dude. Okay.
Dude.
That's a cool story. Physical constant. Yada, yada, yada. Cool story, bro. I'm asking for the model that makes predictions that we can apply in real life.
I propose a simple theoretical formula for describing the refractive indices in binary liquid mixtures containing salt ions. Our theory is based on the Clausius-Massotti equation. It gives the refraction index of the mixture in terms of the refractive indices of the pure liquid and the polarizability of the ionic species by properly accounting for the volume change upon mixing. The theoretical predictions are tested by extensive experimental measurements of the refractive indices of water, acetonitrile salt systems for several liquid compositions, different salt species, and a range of salt concentrations. Excellent agreement is obtained in all cases, especially in low salt concentrations with no.
Are you almost done? Like doing nothing?
Expression of the refractive index for low salt concentration is also given, which can be a theoretical basis for determination of salt concentration using refractive index measurements. So it seems like they've come up with a very, very simple equation for refraction based on this one specific liquid, and it's been correct. They tested it, and it was correct.
Yeah, awesome.
Okay.
Yeah.
So now we're going to apply that to the air. What model is used for the air?
Just a second.
It doesn't matter. There's not a big deviation.
It doesn't matter.
What I love is they're using a tank and a solution and allowing it to set so it becomes homogeneous and isotropic.
Are they?
Yeah.
Are they? Because what I just read out.
Because when you stir the solution, I've seen many demonstrations of this.
Okay.
When you stir the solution, you see no deviation.
Look, I'm just looking for the justification for claiming that there's terrestrial refraction fucking up all our measurements with a laser. I want the justification for that. And you can't seem to come up with one. Other than because I said so.
Experimental determination of the refractive index of Snell's law. This experiment uses a narrow beam of light passing from air into glass and then into air. The experiment is practically easier using a hemi-cylindrical prism of glass with a beam entering the curve.
But these are inapplicable to what we're talking about.
Why?
You're just Googling random shit on refraction, dude. Terrestrial refraction. Google that, brother.
There's
dude, you think I don't know you didn't look for this?
An experiment showing refraction works, but you don't like it because you don't seem to understand that Snell's law, being a model, means that there has to exist things in real life.
You can claim it works in different applications that have nothing to do with. We want to see it works in this application.
In what application? Through air?
The application of a laser or a ray of light through air, dude.
Great. Refraction over water experiment. Have you never typed these things in?
Look, dude.
No, you haven't, have you?
What are you talking about?
It's much easier to just sit here and go around in circles about things that you don't understand rather than just go,
yeah, talking about me again. The old standby.
Hey, so anyway.
No, we're gonna finish this point. I don't care how long it fucking takes, dude. Literally, I don't. So we're gonna finish this. I want the predictive model for refraction so we know that there's a justification for saying that it exists. We need a justification. We can't just say, hey, willy-nilly, we're just going to throw in this phenomenon that we say exists. We need a justification for saying it exists, right? And one justification would be a model that's been tested and makes predictions. But that model doesn't exist, and you know it doesn't exist. That's why you're bringing up all this ancillary bullshit. And you know what? By bringing up ancillary bullshit and
predicting atmospheric refraction with weather modeling and machine learning.
Yeah. Okay. I've read that.
Would you like to read this?
I've already read it.
Have you?
Yes, I have. I read it about 2 years ago.
Oh, okay. What do they do in it?
I think they're looking at the side of a mountain, if I remember right. It's in Arizona. It's like in the desert.
White Sands, New Mexico.
Yeah, I got a pretty good memory. Seeing I only freaking skimmed it freaking goddamn 3 years ago maybe. Yeah, but even if listen, so check this out. I'm pretty sure the AI successfully made predictions, but AIs are black boxes, so we don't know how they actually make predictions.
So you've read something that confirms that.
No, it doesn't confirm anything. They just
weather model data results were computed for 10-minute intervals, and ray tracing procedure was applied. The data is interpolated in time to align with the time-lapse image frames. Shows results of the experiment as a function of time of day. Blah 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 blah. Where is it? Measurements are only available for daytime. General downward drift through daytime hours is an effect we commonly observe in clear weather, and this corresponds to a reduction in the average refractive index gradient of the atmosphere along our line of sight.
Yeah, claiming something and showing the actual mathematics to support it are two different things.
Well, they've got the mathematics in this.
Not for that specifically. That specific claim you just made, they do not have.
I'm looking at it right now.
So what model do they use?
They have a machine learning model.
Well, you said it just matches the gradient of listen, you just said it matches the gradient of the refractive index. What is it matching? What is the machine learning matching? What model is that?
So the machine learning takes the image and then the ray tracing, whatever it is, and adds that into the known distances, and then takes all of the weather data and then calculates a refractive index based off that.
Okay, so what model is it comparing it against?
I mean, I can just link the paper. It's got all the maths for it here.
Yeah. What model does it compare it against? So what you have is you have a model, and a machine learning looks at the images, right? And then the machine learning goes, if this model existed, how would this image match that model? And now I'm going to make predictions. When I take an image, how does this image fit this model?
It doesn't matter. It works.
What's the model, dude?
Refraction exists, and it's between Fermat's, Snell's, and this model. They would have similar outcomes, right?
No.
And the deviation doesn't matter because the deviation can be changed by any of the variables changing. So the refractive index should actually just be like a range, okay? So if you have like the black swan image and then you apply refraction to that, you don't just add a set refractive index. You can make that a range of refractive indexes based off the measurements you have and the variables that could change. That's how science and data works. And then from that, you can see whether that image can fit the predictions based off refraction, which would be the range of refraction.
What predictions? That's what I'm asking you. How do we make the predictions? What model do we use to make the predictions?
It doesn't matter. For math, this machine learning.
I'm going to use chicken bones.
Be fairly similar, right?
No, not really.
Not really. Okay, so what's the
difference? Depends on what model you use. They've tested models. In the literature, they've tested these models against each other.
Well, then why
you actually don't know anything about this topic. I'm asking you this for a very specific...
any literature, champ?
Because they're so... Dude, do you want me to link hundreds of PDFs that say, fuck, dude, we don't know?
I want you to link one.
Hold on.
Here, look, I'll add this in showing that machine learning can predict refraction.
So what? Machine learning is black boxes. We don't even know how it's doing the prediction. If you knew anything about machine learning... No.
That's a genetic...
The machine learning is at modeling anything. You don't understand how machine learning works, so let's not talk about it. Until you know how machine learning works, then there's nothing to talk about.
It's a genetic fallacy.
No,
isn't machine learning where the machine takes in multiple sources of data and then it comes up with an algorithm based off that data that would predict any two sets of data outcomes further on?
Okay.
Let's look. Machine learning, subfield of artificial intelligence that deals with systems that are able to acquire their own knowledge by extracting patterns. There we go. Extracting patterns to get new data. Great. So, have you found that study yet?
Yeah, I'll just read you a whole bunch. How about that?
No, just link one.
Where should I pick?
Have you linked one? Have you dropped one in voice chat yet?
Yeah, I got a link to like 10.
Well, I just want one, so link your best one. I'm going to just look at the top one anyway. Top one better be your best one.
So what? Just so I get the right thing, and I give you the right thing. What exactly do you want?
Show the difference that an observation using Snell's law refractive index versus Fermat's law refractive index.
I already did that.
Deviation.
I'm not doing it again. They don't use Snell's law, and they don't use Snell's law in any type of surveying, anything to do with
they use Fermat's law.
They don't use it.
Why'd you ask which one's best?
No, oh my God, dude!
This is law, so why would you ask?
This is what you don't understand. There's models for terrestrial refraction. They involve temperature, humidity, CO2, yada yada yada.
I explained all this to you, fucking idiot.
Listen, no, dude.
Yes,
there's
I did.
multiple models.
10 minutes ago, I went through all the things that can impact refraction.
That's right. That's awesome. Yeah. That's awesome.
Explain it to you already. So every single image you guys have of a flat Earth can be explained using refraction. We know to exist.
Okay, cool.
Is that true? Yes or no?
Yeah, cool. No, it's not true.
Okay. Great. Give me one image that shows that the Earth is flat that can't be explained using refraction.
Using assumption, you mean?
No,
refraction. Okay. I just went through machine learning.
You just have assumption. You have no evidence that there is refraction happening on those days.
Machine
learning was able to calculate a refractive index.
They're not calculating anything.
Yes, it did.
No, they're not.
You're just assuming things. You have no values, so you're just assuming things. There's more values in the laser test.
The data goes in, it calculates, it comes up with an equation.
It doesn't calculate, it does. It doesn't come up with a fucking equation. You don't know what you're talking about.
When you get data and you run data
dude, machine learning is basically a lookup table, dude. That's basically what it is. It's a lookup table. You have no idea what you're talking about. Dude, I got a degree in computer science. You don't know what the fuck you're talking about.
X equals C, depending on some variable.
That's not. They use gradient descent, dude. In this machine learning model, they use something called gradient descent. You have no idea what the fuck you're talking about. Stay like you don't know what you're talking about with refraction. You really don't know what you're talking about with machine learning.
Even if I don't know what I'm talking about,
I'm not going to explain it to you.
I can understand.
Look, I want to go back to these variables.
Someone who's been doing this for years.
I want to go back to these variables, right? So these variables that you say exist, it's cause refraction. Right? You think they exist because there's models that exist that use these variables to make predictions about refraction. Well, none of these models actually makes accurate predictions.
They do.
No, okay, where is that?
The Fermat's law. You just explained yourself that surveyors use it. Surveyors get accurate data over land masses, don't they?
I'm not talking about. So listen. Okay, so to apply Fermat's principle, you have to know the refractive index at any given point. How do you calculate that?
No, you can average it. That's the whole point of it. Snell's law assumes that there's some set there's some set boundary, but Fermat's law can say that given like the known variables, you can average it out over a distance.
Well, they don't do averaging, but whatever. That's
what Fermat's law is. It may not be an average, but what it is it's going from A to B using a function rather than going from A to B
right.
with
And
some
so there's different
boundary.
variables that they use in these different models to model terrestrial refraction.
So none
are accurate. That's what I'm trying to tell you. None are accurate.
As a function, it would be centimeter 1 is 9 from 1, centimeter 8 is bloody 2, centimeter 2 is 8 from 1, centimeter 3 is 7 from 1. That's how the function would work.
Yeah. Great. Fantastic. How do they figure out what the refractive index is at any given?
Maths. I only I don't know much advanced maths, and I was able to explain to you how that would be.
You don't have to explain it to me. You're just you're trying to convince yourself of something, dude. You're not understanding what I'm saying, or you're deliberately being obtuse.
This is getting sad, all right?
There's a model. There's a model that uses these variables. So you're still going to talk over me again. There's a model that uses these variables, and none of those models make accurate predictions. These variables that you say exist, which cause refraction, to validate whether these models cause refraction, you need a model that makes predictions which are tested and known to be accurate. You don't have that. You're putting the cart before the horse. Where's the fucking horse? Where's the model of refraction that makes predictions so that we know these are the variables that matter? These are the variables that cause uncertainty in our observation. These are the variables that we need to account for so that we can come up with a refractive index or a change in the refractive index from which we can make predictions with. That doesn't exist. And do you know what? It's been tested. So there was an experiment, this laser experiment across the Hawaiian Islands. And they took 3 lasers. And they went from one Hawaiian island to the other. And they did this experiment. They were measuring turbulence in the air. They picked up all 3 of these laser frequencies through their telescope. Then what did they do? So there was other research students there. So for his master's degree, he tried to model it. And when he applied the model of refraction, right? Gradient, standard US temperature. When he modeled it across this same distance using the same laser frequencies, he found out the experiment should not have worked at all. Because the divergence, because refractive index is wave dependent, right? You have, what the hell do they call it? Can't remember the name of it. Dispersion of light. That's where the wavelengths separate.
Why are you still talking? Have you linked the PDF about it?
Oh, I will if you want.
Yeah, of course I will.
I've asked the PDF every single time. But whatever. So, so what happens is the spread of the wavelengths of the laser are greater than the width of the telescope. So when you model it, right? When you model it in this refractive index air, the spread, so you have 3 frequencies of lasers all starting at the same point. They spread out because not all of them refract the same. They refract differently. It's wavelength dependent. So they're spread out by some spatial distance. That spatial distance is greater than the width of the telescope. But somehow they picked up all 3 beams in the telescope at the same time. The only way that can happen is if there's no refraction.
How do I find this?
Hold on, I'm gonna post.
How do I
you want the underlying experiment? Yeah, hold on. So I'll find the underlying experiment. So this was there's experiments based upon. It's done by the Air Force. So the person that wrote this master's thesis, he tried to model what the results were, and when he modeled the standard, terrestrial refraction, using the same shit Visgen uses, using the same shit Mick West uses. Found out that, like it says, I'll read it to you. For the 150 kilometer path simulated, the rays are misaligned by about 4 meters.
Okay.
With respect to the point, the telescope's 3.4 meters wide.
And?
That means they should not have, if the refraction model was correct, they could not have picked up all 3 lasers simultaneously in the telescope. But they did.
What did they say about it?
I mean, what did they say
What was
about
their
it?
conclusion? What was their conclusion?
Well, see, they did the test first, and then after the fact, they applied the model, and then realized our test should not have worked. If they would have applied the model before the test, they probably would have never did it. They would have probably designed a different test.
Okay, so they came up with there is some variable or phenomena that we cannot explain. Is that what they came up with?
What they were testing was, okay, so was
But
the test
was their answer? The presented experimental results on intensity scintillation characteristics reveal complexity of the observed phenomena that cannot be fully explained based on the existing atmospheric turbulent models.
Yeah, so there's turbulence models, there's refractive index models, and he tried to use a mixed turbulence refraction model. None of those models worked, but the turbulence model, called a non-Kolmosov model or some shit. Can't remember the name of it because there's actually two of them. There's the non one and there's just a regular one. Anyway, so the turbulence model fit more closely than the so-called terrestrial refraction model. The terrestrial refraction model says that the experiment should not even have been completed because you can look at the simulation. He simulates it the same way Walter Bisland simulates it, using the same methodology. So the fact that, and I have more stuff, right? So I have more. They've done terrestrial laser measurements using 2-frequency LiDAR. I can post that. And what they measured was the deviation.
What's that going to prove? What's that going to show? What's that going to show?
It shows that when they so-called measured the refractive index, right? They measured the angle of arrival of a beam of light of 2 different frequencies of light. And then they measure the angles, like how much deflection they are measuring, right?
Yes, but the argument. And
they're measuring they're measuring a max 4 mgon deflection, which is equivalent to 0.009 degrees. So if you extrapolate out to 25 miles, that's 8 feet.
And
that's an 8 feet deflection at the max.
And
the laser, like ISO laser test, would have to be a 420 foot deflection. A 440 foot deflection.
And
you don't understand that the observation at Lake ISO is 2 orders of magnitude off the prediction, right? Even if you say you use 76R, it's 2 orders of magnitude off that prediction.
And what was their conclusion?
Dude, for FD core? Yeah, that does not fit the WGS 84 model.
Oh, you're talking about FE core again. They didn't add in any refraction, you fucking idiot.
And I'm trying to justify adding it in. So don't you get it? We're trying to justify adding it in. We're not just saying, yeah, it exists.
The surveys use refraction.
Let's say we use 76R.
Surveys use refraction.
Surveys use refraction. How much refraction
do they accurately measure the surface of the Earth in distances?
For practical purposes, yes.
Great. Do they use optical measurements?
Yes.
Great. So why didn't FE Core do the fucking same?
We can do the same. We can use 76R.
Then do it.
We can use. So if you look, so I'll give you an example. We in the United States, different states build roads. If you look at the surveying manuals for the transportation departments in different states, they all use different refractive index ratios. They use different values for terrestrial fraction. So, for instance, in Massachusetts, they use 0.17. In Washington State, they use 0.13. In Europe, they use 0.13. So different places use different values. Listen, the point is, the largest value anyone uses is 76R, which is 0.166, right? So you take this 0.16 that they use in surveying, right? It only takes 5 meters off. And the value is 137 meters off. The measured value was 137 meters off, dude. So, okay, we'll give you refraction. We'll give you terrestrial refraction model. We'll go 76R. Yeah, now you have to make up another 132 meters.
I didn't say this FE.
Now we can go, okay, there is even double extra special refraction. We'll multiply it times 10.
Drop in the FE laser measurement link again. I'll look at it again using the highest and lowest refractive indexes.
What does that even mean? First of all, you just quoted surveying. They use a 7.6R value.
Stupid rambling way. If we were to add in the standard refractive indexes into the FE core measurement, it still would.
Yeah, the ones you just appealed to, surveying. Those are the ones you just appealed to. You said surveying. They use refraction. That's what they use. They use 7.6R.
Big fella, if you add those into the FE core data, it still won't explain the data. Is that what you're trying to say?
I'm saying if you add that value into listen, I'm explaining it to you. If you add that value into the data, it only moves the laser down 5 meters.
Okay, great.
You have to move it down 137 meters.
The FE core thing again. I'm gonna download it. I'm going to go away. I'm going to do the maths. I'm going to come back. Okay?
Yeah, okay. Fine with me. I want you to keep in mind that they didn't this isn't a one-off. They did it 3 weeks apart. So make sure that you read the dates.
Don't care if they didn't add refraction. I don't give a fuck.
You don't even know why they should be adding it. Other than somebody told you they should add it.
No, I know why they have to add it. They have to add it because as light moves through a medium, if there's any change to that medium, then the angle of incidence changes.
And that means what?
And that means that the light can make things look further up or further down.
Okay. Yeah, you're claiming that. But you're claiming that. But what's the evidence? Dude, that's what you don't understand. You don't understand there's a difference between claims and evidence.
Open the fridge, mate. You ever opened the fucking fridge and looked at it? You cold air when it hits the warm air and things get all goofy behind it.
Well, that would be evidence.
What about experiments? But there's one where some dude pours cold water over, or I think it's liquid natural gas over a propane tank, and you can see some, I don't know, colours that you couldn't see before, some bands of colour.
Thank you for proving. You just proved flat Earth. Thank you very much.
Affecting what you see.
Yeah, that's great, dude. Do you know what that proves? Because you have to use it's butane. Listen to me. Because that proves that you're applying refraction. Listen, you don't get it, dude. Butane has a okay. Can I finish? Okay. So the refractive index is butane, by the way. And the refractive index of butane is 1.33. Right.
I don't care.
So check it out. The fact that you have to use, the fact that you have to use an extreme, non-physical, unequivalent demonstration to simulate what you say is happening all the time demonstrates that it's not happening all the time. The fact you have to use butane to show it to happen demonstrates that it's not happening all the time.
It happens with cold air.
How cold? Yeah, with cold air, but that has a temperature gradient of something like 70 degrees per centimeter. Is that physical? Do we experience that in the real world? Do you ever have your feet get frostbite while your knees were burning off? I didn't think so. The fact you have to use extreme examples of demonstrations, non-physical to what we experience in everyday life, proves that it's not happening.
Oh my God, that's because the demonstrations are done in people's houses, you fucking moron. You fucking idiot. If you're going to demonstrate something in your house, a very small area, then you have to use extreme refractive conditions because you can't have the massive change over a long area. It's numbers, you dumb cunt. It's numbers.
Oh,
what numbers?
The language on you. You blow your father with that mouth?
Oh my God. So you have, say, I want to test something in a very small area. Okay, and I want to test some variable that usually happens over a very long area. I have to make that variable much bigger in the small area to make sure that I can observe that variable in action. Because over the very, very, very long area, that variable can have very insignificant changes, but because it's such a long area, those insignificant changes can cause a massive change over that long area. I'm explaining this to you like a child because so far you've shown that you may be a child.
This is actually pretty humorous. So what you're saying is,
look, here's a video.
We have to scale down the experiment to demonstrate that the phenomenon, which should be happening all the time in the air, is actually possible. And to do this, we need extreme conditions. But the underlying phenomenon, you can't actually demonstrate is happening.
Extreme conditions, just people show that it's possible using extreme conditions because they're doing it in their little house.
But they're not equivalent.
Of course they're equivalent. It's just scale, mate.
Okay.
If I want to make a square, I can make a square 1 centimeter by 1 centimeter or 1 mile by 1 mile, but those fucking squares will still be square.
Okay. It's not equivalent, and the scale's not equivalent, okay? Because the refractive index of air, I'm going to explain to you why. I'm trying to explain to you why the emotional child. Irony of you calling me a child with your spasming, dude. That's hilarious. Anyway, so the refractive index of butane is nowhere near equivalent to air. Air's refractive index changes. Yeah, you don't give a. I thought it was math, dude. I thought it was numbers, but now you don't give a fuck.
Past butane onto air, but you're stuck on butane.
I'm going to cover them both.
You consider anything that goes against your biases.
So I'm going to cover them both. See, don't presuppose what I'm going to say, dude.
Well, don't talk about butane because I don't give a fuck.
No, you don't give a fuck. Okay, so let's talk about the air. The temperature, the extreme temperature gradient, right, that you're demonstrating. So I've seen the dry ice demonstration. The refractive index of CO2 is not the same as air. And then I've seen, I think they use a cold plate or something like that, or ice. I think it was Mick West used ice. Was it Weiss? What did he use to make everything cold? Was it turbulent air?
No, he didn't use Barry Weiss.
What was used to make the temperature gradient?
I don't know, because I'm not obsessed with people that do these experiments like you retards are.
So you cited an experiment that you don't even know what happened. Great, let's go with that.
I've watched. I cited an experiment that I've watched, but I don't remember the people that did it because I don't give a fuck. Look, I found.
So what if they use dry ice?
Let's look at the Mick West.
What if they use dry ice to make the temperature gradient?
You wanted me to talk about Mick West, didn't you? Because you have pre-prepared.
No, I don't care about Mick West. He already got smashed in here. You can fucking listen to the video on the YouTube channel.
Yeah, there's Mick West. I finally found the thing you were talking about that I wasn't.
I don't care about Mick West. I'm asking you, if you don't know the details of the experiment, you don't know if they use CO2, if they use some equivalent. You claim they're equivalent, they're just different scale, but you don't actually even know that. I'm asking you, if they use CO2, why did they change the air? I'm trying to figure out the iron. See, you make claims that there's no evidence for. That's the hilarious part. You just keep
What claim?
You claimed that these demonstrations are equivalent and they're just a change in scale. So I'm asking you details about them and you don't know the details. So you're just talking out your ass.
What detail do you want? The guy put up
what they used to cool the air. What did they use to
laser changed it?
What did they use to cool the air? What substance? How did they create this temperature gradient?
Nothing. They warmed up the air using an iron.
They warmed up the air using an iron? What?
Are you just going to repeat back with a dumbfounded?
I don't understand I don't understand what you mean by they warmed up the air using an iron, like an iron for ironing clothes. Iron, like
you
what?
Don't seem to understand anything. I linked the video.
Yeah, because you suck at explaining yourself.
You know, an iron, like you iron your clothes. Yeah, it heats up the air. Look, here's one of nice wavy air patterns in front of a heater. Why would that happen?
Turbulence. It's called sensible heat flux.
Amazing.
Yeah, it's called sensible heat flux. Yeah. So, like when air gets hot, it goes up, right? Right? It tries to equilibrate and it moves around. It's like why you don't survey in the wind. So there's something called the Fresnel effect, where a medium that's in motion will deflect light in the direction of the motion.
Oh, okay. So there is refraction, deflection.
That's not refraction. It's a completely different thing.
So did they look at what the wind speed was over the water in the FE core experiment?
Yeah, I'm pretty sure they did. I mean, it's on like they took pictures of the meteorological stations.
Anyway, I'm out of here. My earbuds are about to die, and you seem to be thicker than a brick, my son.
Yeah,
hypothesis in science, buddy.
Does that qualify as a wig, bro? I'm sorry to everyone that cut up, but I did not want to let him out of that. Otherwise, we're going to be looping on that shit forever. I'm sick of this guy. I'm sick of looping with this guy.
That counts as a wig with the earbud still attached.
Ew. How about the ear still attached? How much glue did you use on that wig?